All right, so let's pick up with cookbooks, which we're going to talk about next. So what we did before lunch was learn a little bit about resources. Resources follow that test and repair model. I see we have some new faces also. What we should do maybe at the next break is we can help you get caught up, or you can just like watch, which is fine too. That means you're not allowed to ask any questions. That's a lie. You can ask any questions you like. It's true, maybe. But I'm going to give you some playing cards. Since you're.
You brought that, did we steal someone?
Yeah, you should not use that one.
Okay.
You should totally take it. You each have one. You can fight over which one you prefer. And I'm going to guess later which ones you have.
Okay.
So don't tell me.
Our names are.
What's that?
We put our names on our instances.
You put your names on your instances. Yeah, you did. But they're not going to. So they don't even know what the cards are for. They don't know the magic tricks. Don't give away the secret, please. All right, so we talked about some resources. Resources follow a test and repair model. I will tell you that sometimes when you read the chef documentation or talk to people that do chef, they won't use the words test and repair. They'll use a different word. That word might be idempotent. I hate that word, and I think it should be stricken from all of our documentation. Here's why. First, and most importantly, idempotent is a word that is very easy to mispronounce, and sometimes to very humorous effect. But that's not really why I hate it. The real reason why is, how many of you know what idempotent means? Okay, cool. It's okay not to raise your hand, because that helps prove my point. If you don't know what idempotent means, and we tell you that it's idempotent, that doesn't help you at all. If you do know what idempotent means, and you look at the way test and repair works, you will say that is not idempotent. That is maybe convergent. Convergent might be a good definition of that, but it is not idempotent. And those of you that are like, well, what's the difference? Don't worry, just test and repair. That's the terms that I prefer. Those are the ones that are right. If you want to know what idempotent is, you're probably already on Wikipedia, like looking at idempotent and getting the full definition and saying, oh yeah, I see what he means. It's not really whatever. So we can talk about that at lunch or at happy hour after if you want. All right, so let's talk about cookbooks. A cookbook is like a package. So we wrote a recipe. With Chef, what we're going to do is we're going to store those recipes and other supporting files into cookbooks. We actually looked at a cookbook. We looked at that HTTP cookbook that I put to our delivery pipeline. So each cookbook may have a recipe or more. We'll definitely have a metadata file, which includes things like a version number. So as you're writing your source code, as you're writing your recipes and your chef code, you're going to put them into cookbooks, or put those recipes into cookbooks. You'll work on those, and then at some point you'll be ready to take that cookbook and publish it to a chef server. Now, we probably won't actually use a chef server at all today, because you don't have to use a chef server, and you certainly don't have to for the lightweight stuff that we're doing as part of our labs. I'll show you like what that feels like and what it looks like. But we want to put all of those things into a cookbook, and that's the thing that gets distributed. So your cookbooks are typically going to map one-to-one to a piece of software or an application that you're writing. So you're not going to have a single cookbook that is everything that stands up your entire application, but you might have a cookbook for your web server, a cookbook for your database server, like to stand up MySQL or to stand up Nginx, another cookbook to stand up like your application bits. Now, on a particular machine, you might run multiple cookbooks, and in fact, you'll run multiple recipes as part of that machine's configuration. But if you keep these things at sort of a single purpose, what you can do then is reuse them as building blocks. So on my list of examples here, the one at the bottom is NTP. We probably want to synchronize our time on all of the nodes within our infrastructure. It doesn't matter if it's a database server or a web server, the clock on those should be synchronized. So NTP we're going to put everywhere. We'll only put the MySQL server recipe onto the database cookbook. The application nodes might get the MySQL client recipe. So we can just manage these things a little bit more cleanly by putting them into cookbooks. Yeah, so this is what we do. We package code, we version that code, and where possible, it makes sense to separate the data from the policy. What do I mean when I say that? If you've ever done web application development before, you've probably heard people talking about, like, keep your data out of your views, like keep those two things as separate concerns. This is kind of the same idea. We can do data-driven development with, or data-driven infrastructure with Chef as well. So for example, let's say our policy says that Tomcat should be installed. Our data might tell us which version of Tomcat should be installed. So should I install Tomcat 7, Tomcat 8, Tomcat 6? Who knows? That's a data attribute. The policy is the same. The data can help change that policy. So today we have this Apache cookbook, and we're storing the contents of our homepage directly in that recipe. And I said Apache cookbook, I meant Apache recipe. Well, let's separate these two things out. Let's move the content out of that recipe and into its own file. So in order to do that, we're going to use another tool from the Chef development kit called Chef. So there's a command line tool called Chef, much like Chef Apply. This one is just called Chef. It's included with the Chef DK. I'm going to use that. So what we want to do is create a new cookbook that's going to be our Apache cookbook. We need to store that cookbook in version control. So we want it in some Git repository. And the thing that we're going to do is we're going to create a Chef repo. And this is just going to be a directory. We're going to call it Chef repo. It's basically going to be the repository for all of our Chef infrastructure code. And then within that repo, we'll create an Apache cookbook. So if you log back into your machine, I'm going to do that on mine as well. If you haven't already done so, now would be a good time to do so. Do Chef, I don't know what the slide said, Chef generate help. So Chef, let me tell you a little bit about the way these command line tools work. So there's this command line tool called Chef. It has a bunch of sub commands that it can run, much like Git has a bunch of sub commands, like git add, git commit. These are sub commands of Git. Chef works the same way. And as you walk down the tree of sub commands, you can run -- help at any step along that tree. So you can do chef space -- help, and it will tell you the things that Chef can do. You'll see one of the things that it can do is it can generate things. So if you do a Chef generate -- help, you'll see the types of things that Chef can generate, one of which is a repo. And the repo is going to be a repository for your Chef code. So that's what we're going to do. So I'm logged into the machine. I'm in my home directory, and I'm going to do the Chef generate repo. And I'm going to call that Chef -repo. Now, the name that you give this repo doesn't matter, but by convention across sort of the Chef community, people will call this the Chef -repo. And if you did what I just did and hit enter, that's cool. If we look at the slides, we'll see that the slides told us to use yet another argument, a -p. But since we didn't use it, I'm not even going to talk to you about it. We're just going to blow right past that and assume that I didn't mean to put that in the slides, which is cool. But what you can see here, when I ran the Chef generate command, this output looks much like the Chef output that we saw when we ran Chef apply on our Apache cookbook. And as it turns out, with the Chef generate, we're using Chef to generate stuff for Chef, right? So this ran a recipe behind the scenes to generate a directory called Chef repo. And so if we look now in our directory, or in our home directory, what we'll find is that you now have a folder called Chef repo, one called cookbooks, one called Learn Chef, and then a file that's your name. I have other things because I'm pushing all of this content to Git as we go, to GitHub as we go. So if I cd into the Chef repo and do a git status, what you will see is different than what I see. I'll see that I have untracked files which include this directory. What you'll see is this is not a Git repo, right? So what I'd like you to do here, I'll type the command, but I'm not going to hit the magic key, is just run git init. that will initialize a Git repository in your Chef repo. And then you can do a git add dot. So git add this directory. And then if you run a git status, you'll see that you have a bunch of new files, a git ignore, a license, a readme, a chef ignore, cookbooks, data bags, and so forth. And then let's just git commit that. I did git commit -m, and then I gave it some commit message. And what I should do also, and I'll do that in a second, is I will push those changes up to that GitHub repository. So we've created a Chef repo. We did that by generating our repo using the chef command. All right, so the next step is to create an Apache cookbook. And as it turns out, the chef generate command can also generate cookbooks. So you can run --help and see what are the different parameters you could pass to that. What we're going to do from your chef repo, cd into your cookbooks directory, and then run this command, chef generate cookbooks Apache. Let me push up my changes and then run the same thing.
So did you guys do it with Knife?
Did we do away with knife? That's a great question. We did not do away with knife. Give me 1 second and I'll answer that question a little bit more completely. So here I am in home, chef repo cookbooks, and I'm going to run chef generate cookbook Apache to generate that cookbook. Now, if I ls cookbooks, sorry, I'm in cookbooks, if I ls Apache, you'll see that Apache now has a Burks file, a chef ignore, a metadata, a readme, a recipes directory, a spec directory, and a test directory. So now let me come back to your question. Did we do away with knife? So how many of you have heard of knife before? Okay, so knife is another command line tool that you get with Chef. In fact, you have knife installed on this workstation. You can run a knife -- version, and you'll see that knife is there, and it's probably Chef 12.4.1. Now, knife has some overlapping functionality with the chef command. Chef will replace some of the components of knife. The chef CLI will replace some of the components of the knife CLI. Chef, though, is primarily focused on what does the cookbook development workflow look like. So if you're familiar with knife, what you might have done in the past is knife generate or knife cookbook create Apache. That might have been how you created this cookbook. Well, the cookbook that Chef gives you is slightly different than the cookbook that Knife would have given you. And if you want to compare the differences, you could run that Knife command and then look at the two different directories, give it a different name so you can do a diff against them. But what we found with Chef, what we set out to do with the Chef development kit is make your life easier as a cookbook developer, as someone who is authoring infrastructure code or authoring Chef code. We want to make your life easier. And so the Chef development kit is how we do that. The Chef development kit includes a bunch of things from the community that we think are the best tools for part of your workflow. Things like Test Kitchen, things like Chef Spec, things like Burke Shelf, which we're going to look at some of those things here in just a minute. With Knife, when you installed Knife, all you got was Knife, basically. With the Chef command, you get a much cleaner cookbook. There are things that Knife does that Chef doesn't do and likely won't ever do. For example, with Knife, I can query my Chef server and say, hey, tell me all the nodes that are running Ubuntu. I will continue to do that with Knife, where I'm interacting with the Chef server, not with the Chef command. Cool. All right. So I think what I'm going to do now, if you're following along on the slides, I think what I'm going to do now is throw out the slides. And we're gonna, in order to do that, I mean, the reason that I want to do that is I kind of want to skip some of the stuff that's in the slides so that we can get to the more interesting bits. You guys, are you okay with that? It's good, because if you said no, I'd say, too bad, I'm at the front of the room. This is what we're gonna do. So here we go. Let's think about our Apache cookbook. One of the things that we, so here's our goal. We wanna move the contents of that homepage into a template. We wanna do that. That's one thing we wanna do. But we wanna make sure that it's going to work for us. And the way that we got Apache working for us right now, our Apache recipe, was we wrote the recipe and then we applied it and then we checked, did it work? And this feels like a bad practice to me. This is almost as if we wrote some code, put it in production, and ran it to see what would happen. Let's not do that anymore. Let's start by writing tests for our code and make sure that we understand what is our code going to do and utilize some of our testing tools. So when I said I'm not going to use the slides anymore, I kind of lied, but I'm going to skip way ahead to a couple, like a couple of sections ahead at least. Yeah, let's go here. This will be better. This will be a much better use of our time, I think. So let's automate this testing. What we've done so far is write the policy. We wrote a recipe. We applied that policy. We checked to see what would happen. Let's automate all of that away. So when it comes to testing your infrastructure code or testing your Chef code, there are really 4 questions that we need to answer. The first question is, did the Chef client complete successfully? Now, when you wrote your apache.rb and did chef apply apache.rb, did anyone have a failure? Yeah, sure. People have failures when they write recipes all the time. If you've ever written Chef code, you've seen Chef client bomb on a recipe that you wrote. So if we can answer this question before we put it in production, we should feel a lot better. Did the Chef client complete successfully? Of course, that's not enough. Then there's the question of, is the node in the desired state? Are our resources properly defined? And are we following our style guide? What I'd like to do is explore the tools that will answer all 4 of these questions on our very simple cookbook. This will give you exposure to all of those tools. So let's start with the first one. Did the Chef client complete successfully? In order to answer this question, we need a couple of things. The first thing that we need is a place to store that cookbook, the cookbook that we generated. Where are we going to put that? And the second thing that we need is a Chef client that can actually execute that cookbook or run the recipes from within that cookbook. And then we also need a target server that's running the same operating system as our production environment. If I look around the room, most of us have a Mac in front of us. How many of you run MacBooks as your production infrastructure? Right. So like testing your infrastructure code on your MacBook, maybe not the best test to figure out if it's going to work in production. In fact, if what your recipe says is brew install foo, and then you go and try to run that on an Ubuntu machine, guess what's going to happen? It's not going to work, right? So we want a target or a server running the same operating system's production. And this is where our first tool comes in. That tool is called Test Kitchen. How many of you have heard of Test Kitchen and used Test Kitchen? All right, a couple of people. So Test Kitchen is a way for us to very easily spin up virtual machines in which we can execute our Chef code. It's like a test harness. So if we think about it, when we're writing cookbooks, we may be targeting multiple platforms for these cookbooks. Maybe I want this to run on various versions of Ubuntu. Maybe my infrastructure is Ubuntu and CentOS. Maybe it's Ubuntu, CentOS, and Windows. How many of you have one version of one operating system in your production environment only? Right. Yeah? Yeah. You think so? All right. That's awesome. Never quit that job. Never, ever, ever leave that place. That sounds amazing. But typically, that's not the case, right? But you're the exception that proves the rule, so I'm glad you're here. It's awesome. But so if we have 2 operating systems, then we just doubled the amount of testing we have to do to make sure that things are working well. So if we have 2 different operating systems in one recipe, we need to spin up 2 virtual machines and execute this recipe on both of those to make sure that it works well. But this can get complex very quickly. So what if we have two recipes that we need to test? There's a default Apache recipe, and then there's one that configures SSL for us. Now I have to stand up 4 virtual machines. And what if I decide that I want to target a different version of the operating system? Now I'm standing up 6. And so you can see that this gets quickly complex as you build out this test matrix. Test Kitchen is going to make it easy for us to model and manage that test matrix and that infrastructure. So what I'd like you to do is in your editor, go ahead and open up, there's this file here called cookbooksapache.kitchen.yaml. So you can just open that up in your editor. And it's going to look like this. This is a YAML file. I want to walk through the various sections of this YAML file. There are basically 4 different stanzas. The first stanza is the driver. So I said that Test Kitchen is going to spin up virtual machines for us. So the question that you might have is, where are those virtual machines going to live, or how is it going to stand up those virtual machines? That will be determined by the driver. So by default, Test Kitchen, the kitchen YAML that we get from the chef generate command, is going to use the driver of Vagrant. Have you used Vagrant? No. Some have, some a little bit, some not so much. So Vagrant, I'm going to say some words that are a lie, but there are enough truth that it's fine for today. Vagrant essentially is a Ruby wrapper, like a Ruby application that wraps around Oracle's VirtualBox. That makes it very easy for you to spin up virtual machines in Oracle's VirtualBox. VirtualBox you might install on your Mac or on your Windows box, and then use Vagrant to create virtual machines within that VirtualBox. Super easy. Now, that's not a lie per se, it's just not the whole truth. So if you're well familiar with Vagrant, you know that there's a lot more to it than that, but that's all we need to know for today. So depending on the driver, this will determine where we spin up those virtual machines. Vagrant is nice because it all just happens locally on your machine. And Vagrant is terrible because it all happens locally on your machine. As that test matrix gets bigger, wider, and deeper, right, you're going to spin up, I don't know how many VMs, maybe 40 different VMs. Do you want 40 VMs running on your local machine? Maybe not. So there are other drivers, like there's an EC2 driver that you can connect to Amazon's EC2 and go and spin up nodes there. There's a DigitalOcean driver where you can go and spin up nodes there. Basically name an infrastructure as a service provider, and there's a driver for that thing. You can also spin up nodes, say in Docker, if you want to launch containers instead of full-blown virtual machines, which is what we're going to do soon. So we have the driver that determines where those virtual machines are going to go. The provisioner is the application used to configure the node. So we're going to use Chef 0. Now, Chef 0 is essentially the Chef client with 0 servers involved. So Chef client is the way you will typically run Chef in your environment. Because of the word client, it kind of implies that there's a server somewhere. So in a normal operating environment, you're going to have Chef client running on your nodes. The Chef client is going to ask the server on a regular basis, what is my policy? What recipes should I apply? It will download those recipes and apply those here on this node. With Chef 0, we just make the assumption that the recipes, the cookbooks that we want, are all local. And I don't need to go talk to a Chef server. That's the big difference between the two. So I'll use that provisioner to configure this node. Next, we have our platforms. So what are the operating systems that we're targeting? So in this case, by default, probably this is a little bit different than what you see. Ubuntu, you probably see 14.04 and probably CentOS 7.1 or something like that, right? That all came from the chef generate command. And then finally, you have your suites. So your suites are the run lists that you want to apply with your provisioner. In other words, the recipes that you want the provisioner to apply to this node. So we're going to apply the recipe in the Apache cookbook, the default recipe. We're going to apply that recipe using Chef 0 in virtual machines that were spun up by Vagrant. One virtual machine for Ubuntu, one for CentOS. Does this make sense? Are there questions I can answer for you about the Vagrant YAML or what the heck Vagrant is, or I'm sorry, Kitchen YAML, or what the heck Kitchen is, or how we're going to use it?
So, I'm into stuff and I don't get this file. You tell me what you did to get it?
Yes, we did the Chef Generate Cookbook Apache. Did you do that?
Right, I did. So
The problem is it's called .kitchen.yaml. So you might just not be seeing it because it's a hidden file.
All right.
Sure. Okay, we are going to change your kitchen YAML. So make sure you have it open, and here's what I want you to change. I want you to change the name of your driver. We're not going to use Vagrant, we're going to use Docker. I want you to add a new line after the driver name, and it should be use_sudo, and I want you to set that to false. That should be indented 2 spaces, just like the name is. And then the third change that we're going to make, we're going to pull CentOS out of this. We're only going to test on Ubuntu for today. At the end of the day, if what you'd like to do is make your recipe work on both platforms, you can come back in and add that in as sort of an exercise left to the student. So the 3 lines that are changing, the name, use sudo is a new line, and then the platform, we only went to Ubuntu. So I'm going to make those same changes myself.
So this is that we're testing. I don't see a kind of a test that.
Right, we're going to get there. So the first question is, does the Chef client complete successfully? That's our first question that we're going to answer that first.
Too high on that.
Is that?
Too high on the.
Yes.
Do you want driver or Docker?
I definitely do not want driver. Thank you. That's right. Yeah, because I clearly had no typos before lunch. So it's definitely, like, the only thing that's different are the margaritas. So driver, Docker, use sudo is false. And then the platforms are Ubuntu. Use sudo should be false, right? That's what I told you to do?
Yeah.
Okay, great. And then Ubuntu 14.04. So now let's test that kitchen, your kitchen configuration. So to test it, make sure you're in the right directory. You're in Home, Chef, Chef Repo, Cookbooks, Apache. And what I'd like you to type in is kitchen list. And what's going to happen is one of 2 things. You're going to see a list of your kitchens, or you're going to see a big error message in red. I mean, it might not be red, but it will be a big stack of this is bad YAML. Who sees a stack of this is bad YAML? It would be awesome if someone did.
I have an exception.
Yeah, that's probably good. May I look at your exception? Can you go back into your kitchen YAML? That should be use sudo, not user sudo. Try that. Let's make file stand here. Yeah. What's your name?
Bill.
Bill. So Bill had a common error. It happens all the time. He typed the word use and it turned into user. Like it was just muscle memory. It just happened. He didn't mean for that to happen. And so when he did that, and then he ran kitchen list, this is what he saw. There's a kitchen user error. You must first install the Docker CLI tool. So what happens with the kitchen's Docker driver, it tries to figure out, is Docker installed here? And the way it figures out is Docker installed here is it runs a command called sudo docker, and it sees if that command fails or works or bombs or whatever. And so if we tell it not to use sudo, it will work properly. Did anyone else get an error that I can demonstrate? Cool. Okay, so kitchen list shows us this. Mine is formatted poorly, but yours is better. The instance, the driver, the provisioner, the verifier, the transport, and the last action. So the instance is going to be a combination of your suite from your kitchen YAML. If you open up your kitchen YAML, you'll see that there's a suite at the bottom. Its name is default. And then it will have a dash, and then it will have your platforms listed. So we only have Ubuntu, so we have an instance called default Ubuntu 14.04. And it will tell us the driver and the provisioner. We haven't really talked about the verifier or the transport, but maybe at least the transport should be kind of self-explanatory. And then our last action is not created. So let's go ahead and create this kitchen. In order to create that, what we're going to do is type in kitchen create. And it's going to run through a bunch of stuff here, and hopefully it will complete successfully. By hopefully, I mean it will probably complete successfully, and if it doesn't, well, then we'll deal with that. But while that's running, let's look at some slides. So what's happening as this gets created is we are going to, on our workstation, spin up a little virtual machine that is our kitchen. Of course, it's not really a virtual machine, it's going to be a Docker instance. Have you used Docker before? No, some yes, some no. Okay, so I'm going to say some things about Docker now for everyone that hasn't used it before, and everyone that has is going to want to punch me in the face after I say these words, but it's good enough for today. So what you should do is consider Docker just a very lightweight virtual machine. That's all it is, which is a lie, and those of you that know what Docker is, want to punch me, it's cool. We're just going to stick with that definition for today. It's a lightweight virtual machine. So when we say kitchen create, it creates this little kitchen for us. It's another container. It's like a little virtual machine on our workstation. And what you can do is kitchen login, unless it failed. Did it fail or it worked successfully or it's still going? Still working, great. I'm on step 17. How about you? Yay, kitchen finished. Yours failed at step 12. Okay. Who else has failed? Okay, if yours failed, this is what I'd like you to do. Watch up here. I'd like you to type in sudo service docker restart, and then hit enter, and then I'd like you to do a kitchen create again. And if it fails again, then what I'll probably do is ask you to take a new card and start over on that machine. I don't know what's going on, because what I'm not is a Docker expert. But when it's done properly, and also it's not you, it's me, or it's that machine. It's definitely nothing you did that was wrong. But if you do a kitchen list, you'll see that its last state was created. You can also run this command kitchen login, and kitchen login will use whatever transport layer we've defined, which was SSH, and it will log you into the test kitchen. So you can do like a PWD, and you'll see your home kitchen. You're no longer on your machine. Your prompt has changed. What's up?
My kitchen finished successfully, but then the line after that says that finalized that the stream was freed from each other.
Yes. Have you seen Ghostbusters?
I have.
Okay, so you know what happens when you cross the streams.
Yes.
So we free the streams prematurely so that that cannot happen. Okay.
So that's successful.
Yes. Yeah. So that's like it's just a little warning. It was recently introduced, and all I can do is give you a dad joke about it. So, yeah. But a pretty solid one, I think. Yeah? Yeah? Yes?
Everyone worked okay, but you didn't see what you did again.
Aha! I typed kitchen space login. You bet. What other questions can I answer for you?
Can you do kitchen help, like you were showing before?
Oh, yeah. I believe you can. Let's just see. Kitchen. Oh. And indeed, do kitchen help. Yes. And then with each one of the things, like you could do kitchen list help, and it will tell you like more information. So as you step down those subcommands, you can get more pertinent help data. Okay, so we kitchen logged in. We poked around. We see that it is clearly a different thing. So when we ran kitchen login, we made an SSH connection into that test kitchen. We poke around. We aren't going to do anything there. I just wanted to like make it very clear that you have your workstation that you're logged into, and you just spawned or created a little VM on that workstation. Yeah.
If you have multiple, like different versions of.
Yes.
Yeah.
So how would that work? So the way that it would work is when you do kitchen login or many of these kitchen commands, you would then also include enough of the instance name or the instance ID to delineate which one do you mean.
Okay.
So if, as an example, if you said kitchen login and you had 3 test kitchens, kitchen would say, I don't know which kitchen you want me to log into.
So it would error out.
Yes, it would error out. But then you could say kitchen login Ubuntu. If you had Ubuntu and CentOS, you could say kitchen login Ubuntu and it would log into the Ubuntu machine. You could say kitchen login CentOS and it would log into the CentOS machine. Some commands, like the one that we'll probably run next, if you ran that command, it would apply it to all of your test kitchens at once. You wouldn't have to be specific. But login is a thing where, like, you have to log into one machine. You can't. It's not going to like spawn 3 different shells for you and give you like split your panes on your terminal, and that would not work. All right. So what we have now is a target server running the same operating system as our production environment. It doesn't yet have Chef Client with access to the cookbook, so we need to do that. We haven't applied our policy to our test environment yet either. So there's no policy, no recipe has been run in that test environment. So let's do that. Let's exit out of your kitchen. Make sure you're in the right directory. And you should be in this directory. You shouldn't have to CD here. But if you typed exit one too many times, you might be back on your workstation and maybe not know it. So if you go to there, if you have that, then good for you. But what we're going to run next is Kitchen Converge. And I'm going to run it as at the same time as you. So Kitchen Converge. What Kitchen Converge is going to do is log into that kitchen for you. It's going to say, hey, is Chef Client installed here? It's going to see that Chef Client is not installed, and it's going to install it. And then it's going to take the cookbook, move that cookbook into the kitchen, and use our provisioner to apply that cookbook, to apply that recipe to the test kitchen. So it installed Chef Client, it took our Apache cookbook, put it into that test kitchen, and then it ran Chef 0 and applied our suite. Our run list was recipe Apache default, or the default recipe from the Apache cookbook. And now it's done, and you can see that it says Chef Client finished 0 of 0 resources updated. Why didn't it update any resources?
Because it did it when you created it.
Because it did it when I created it. So if I log in and curl localhost, I should see my home page.
Because we didn't copy the Apache to RD.
Yeah, we haven't actually written a recipe yet. Right? We haven't written a recipe in our Apache cookbook yet. So if I logged in and did curl localhost, it would fail. Right? Because if I look at recipes default, you'll see that all that's there are some comments. This is the default recipe that the Apache Chef Generate Cookbook Apache gave us. It's just a shell, just a skeleton. So in order for this to work, we need to then take our recipe and put it into, put our recipe into that node. But we're gonna hold off on doing that for just a second, because I wanna go back to our 4 questions and sort of continue down this storyline. So did the Chef Client complete successfully? Did your Chef Client complete successfully?
Still downloading.
Still downloading. It's odd. But it's gonna be fine. We're gonna move on. And when you're lost, you know, or like if it fails, just let Adam know. Okay, so we want to verify that our node is working properly. Like that's not gonna work for us yet. So if we stuck with the slides, we would have written our recipe and applied it without writing any tests. That feels wrong to me. I think we should write our tests first before we write code, because that's more like test driven. So what we're going to do is we're going to write some tests that will validate the state of that infrastructure. So that second question, is the node in the desired state? If we log in now and run curl, we'll see that it's not in the desired state. But applying code, logging in, and checking it is not the way we want to move forward. So we're going to write a test kit, a server spec test. So you should be, again, in your Apache cookbook. And what I'd like you to do is open up this file in the Apache cookbook. So you're in home, chef, chef repo, cookbooks, Apache. There's a series of subdirectories, test, integration, default, server spec, default _ spec.rb. When you have that file open, Could you just like, I don't know, throw a hand up in the air just so I know? That's good. Now, if you have a question, also put your hand up in the air, right? So now I don't know what's the thing. I'm going to assume that you all have this file open and it looks something like this. And I just want to talk for a minute about this. So this is server spec. Server spec is a library that's built on top of RSpec. RSpec is a Ruby testing language or a Ruby testing framework. The way that your server spec tests are going to work are kind of like this. This is a general sort of expectation format. You're going to describe a thing, describe a subject, and if you look at yours does a describe Apache : default. So we're describing the default recipe from the Apache cookbook. And then you will have some blocks that are it blocks. So it and then some description. And I think right now yours says it, replace this with something meaningful. And then within the it block, you'll have some expectations. You'll expect a thing to maybe equal some results, to do something, or what have you. Let's write a very simple test just so that we can understand how all these pieces fit together. And how many of you have ever written like automated tests like this before? Okay, cool. And if you've never written automated tests like this before, but know people who have, I'm going to show you the test that everyone writes in just a second. We're going to do this together, actually. So let's, you probably already have that file open. I'm going to open mine up. We're going to get rid of this it does something. We're going to say it is awesome. And then instead of saying skip, I'm going to just type and then bless you. I'll let you type that and then I'll read it to you and talk about it. Okay, so we're describing the Apache default recipe. We're saying one of the things that describes this recipe is that it is awesome. And to prove that it's awesome, we are going to expect that true will equal true. Can you think of a way to make this test fail? Neither can I.
Quantum physics, I think.
Quantum physics, perhaps, yes. So for those of you that have never written tests before, but maybe know people who have, this is all their tests ever actually do. That's why they never turn red. Because all people do is expect true to equal true or false to equal false, and then your tests pass all the time. But let's just run this test to make sure that like we've got all the pieces configured properly. So I'm going to write and quit this file. And to run our test, I'm going to run this command, kitchen verify. And what kitchen verify is going to do is use our busser to install server spec into our test kitchen. Now, what does that mean? Doesn't matter. It's putting server spec, the server spec library, into your test kitchen. And then it's going to upload our tests and execute our tests. So you should see output that looks like this. We're describing Apache default. It is awesome. That test passed. We have one example and 0 failures. So now we have a passing test. The build is green. Let's ship it to production. Not actually what we're going to do. But this is the path on which we're heading. So now what I'd like to do is go back into that test. And I have a question for you. So like, let's say that what we want to do is actually test that our Apache cookbook does what we expect it to do. What would you want to test to validate that? What would you do to automatically validate that the node is in the proper state? You might test that the service is running. What else might you test? I'm sorry?
Is this going to be expected?
Yeah. Are you reading the, I mean, I realize I gave you all of the answers already, but I'm still asking the questions. It's cool. You can read them if you like. What, maybe one other thing. It's returning a 200. Yeah, that's a good one. I'm I'm sorry?
Returns hello world when you
It
curl.
returns hello world when you curl it. Yeah. I'm going to stop at these 3. Not because I don't love yours, because I love yours. But I'm just going to stop at these 3 for right now. But what I want to do is point out that all I've written in my tests right now are the it statements. I haven't written the block. I haven't written the expectation yet. And there's a reason that I do this. When I sit down to write tests, I think about what are the things that I want to test. I'll write them out like this, and then you can do this along with me. If you run Kitchen Verify again, what you'll see is 4 examples with 3 pending. And if you scroll back up a little bit, you'll see the output that server spec is going to give you. The reason I like to do this is I want this output to make sense when I come and read it. If one of these tests fails, the thing I'm going to look at first is the output, the English that was output from that failing test. So I want to make sure that this is pretty good English here. So Apache default is awesome, is running, is listening on the expected port, and returns a 200. Like I would say that returns a 200, like maybe we could be more descriptive there, like it returns an HTTP status code of 200. So I might refactor just those lines. But it's also, the other reason I do this is to point out that those its, like the strings that follow the word it, don't matter. They're for you. They're not for the computer. Or they're for you and your teammates. But now let's go back in and actually implement these tests. I'm going to go back into this file, and it is running. I'm going to add my do and my end. And here's how I write that. I expect service Apache 2 to be running. Now this is the value of server spec. Our spec, which is the language that it's built on, gives us that generic format where we describe a thing, it has a bunch of ifs and then some expectations. What server spec gives us is the ability to talk about things in a domain-specific language that's built for servers. So server spec understands this word service. It knows how to check, is a service running? And then it also gives us this matcher to be running. Like, it's not true, it's running. Or you could say, I expect it to be stopped. Let's go ahead and implement all 3 of these while we're here. The port is another thing that server spec understands. So I expect port 80 to be listening. And then the last one, I'm going to cheat because in my head, I don't know how to test exactly for this. So I'm not going to because that's my prerogative. What I'm going to test instead is that oh, that wasn't good. Well, you know, I'm going to test yours. I like yours better. Yours was better. What did you say? You wanted to make sure that it says homepage says hello. Sure, something like that. Now it gets tricky. This one, I have a tendency to mess up, so I'm going to type it in a very specific way that you might want to follow along with me. So I'm going to expect, jeez, see how tricky it is? I can't even type the word expect. I'm going to expect something to match hello, and I'm going to do a little I after that because I don't care about case sensitivity. So I expect a thing, I have to describe what that thing is, to match, I think, I'm not sure about that word match. I'm gonna change it to contain, because I'm sure that contain is right. They both might work, but I know contain is gonna work. To contain a regular expression. So if Ruby scared you, then regular expressions should also scare you, unless you love Perl, and then you've got regular expressions down, which is also awesome. So regular expression, we're just going to put between these 2 slashes. So I'm gonna look for the string hello, and I don't care about case, so it's a case insensitive search. So now let's go back into that expect. In order to do this, what we might do is curl localhost and then inspect the output of that curl. So I'm going to expect a command, let's see, command dot standard out. I think it looks like that. So I expect the standard out of the command to contain the word hello. And then all I need left to do is put in the command. What's the command I expect to return that? And that's going to be curl HTTP local host. Oh, easy for me to type. And then I think all of my parens line up the way I expect them to. Yeah, that looks pretty good. So I expect the command curl localhost. I expect its standard out to contain the word hello. Does this all make sense? Have you run Kitchen Verify already? Did it fail because your tests are failing, or did it fail because you wrote bad code? And by you, I mean me. Good question. I don't know either. Why don't I run Kitchen Verify? Maybe I'll get what you got. Yeah, that looks right.
We'll look at that when we. Never mind, I don't know.
Okay. So let's just look at the output and see what's happening here. So Apache default is still awesome, although all of our other tests are failing. So by some definition of awesome, it is still awesome. So it's running failed, and you can see that Apache default is running. It failed. It expected that to be running, and you can actually see how is server spec going to test to see if that service is running. So it's going to test in a way that you might test also. You might log in and do a PS to see if that thing is running. That's what server spec is going to do under the covers. It expects port 80 to be listening. So it's going to use netstat to see, hey, is that port listening? That's cool. And then it expects the command, you expect its standard out to contain a thing. Standard out looks like it might be wrong. It might be standard underscore out. So how can you check? The best way to check is to go to serverspec.org, except that's a terrible way to check. The best way to check is to ask me to go to serverspec.org for you, and I'm going to tell you why in just a second. So I'm going to look at resources, and then I'm going to look at command, and I'm going to see.
Standard out, you just don't have any standard out because the output is on standard error.
Oh, right. Of course. Thank you, Adam. It's always good to have a proper sysadmin in the room when you teach Chef, and Adam is that. There is no standard out when it's a standard error. Duh. All right, so it's all good. My code is fine. I told you my code is always shippable. Always shippable. How do we fix this? What do we need to do? Yeah, we need to write our recipe. So let's go ahead, and you have two options here. You can copy your apache.rb into recipes.default, or you can rewrite that recipe. I'm going to rewrite the recipe because that's how I roll. I like my recipes to be bespoke, like handcrafted. Yes?
So if I wanted to write a test that basically said that if I curl localhost,
Yes.
I don't get a standard error, what would you do for, because the syntax is .2, how do you do like a not to?
You would do just that. It would be not underscore 2.
Oh, okay.
Or .2 not. And I think that they both, like, they're synonyms for each other,
Okay.
like not underscore 2 and 2 underscore not. And the reason that there's like, so do you like gooder English or better English? You can do not to or to not, like whichever makes more sense to the reader, basically. Not Apache 1. That can be fun.
Apache RB or default RB?
I'm in default RB, but what you could have done is just copy your contents of apache.rb into the default.rb. You don't have to rewrite this. Does that make sense? It doesn't. I can tell.
So I believe somewhere we're referring to default.
We are, but so you can't copy the file apache.rb into this cookbook, but you can copy the contents. You could like rename it as default in this cookbook, or you could copy the contents of that file into your default.rb. Yes. And you had a question also.
Yeah, why shouldn't we be going to server spec?
Why shouldn't you be going to server spec? Oh yeah. I went there. I told you you should never do this. You should ask me to do that, and then Adam saved me, and then I moved right on. Here's why. If you look,
Being on Twitter and also like,
yeah, just ask Adam. If you look at the server spec documentation, and you look at the way that these tests are written, they look completely different to the way we're writing our tests. So as it turns out, in the RSpec framework, there were two different sort of syntaxes or different conventions that you can use. You can use this it syntax, like the should syntax, or you can use the expect syntax. If you read the FAQs on server spec, no lie, he will say, like the question is, isn't the should syntax being deprecated from RSpec? He will say, the author will say, yes, the should syntax is being deprecated. You should only write your server spec tests using expect. But I prefer should, and I don't feel like updating the documentation, so all of the examples will use the should syntax, not the expect syntax. And what you can do is give him a pull request to say, please, just fix it. And what he will do, sorry, I think we lost network there for a second. Right. Let me finish my recipe. Thank you for the question. It definitely didn't throw me off at all. It's good. Or get me in any trouble. So I've written my recipe. I hope I wrote that right. Did I finish? If I run kitchen verify, what's going to happen? It's going to fail. Why? Exactly. I haven't applied the recipe yet. So how do I apply my recipe? Right. I'm going to run kitchen converge. Converge is the verb that we use that says install chef if it's not already there and run my run list. So I run kitchen converge. It sees that chef client is already there. It uploads my Apache cookbook. And then it's going to converge my 3 resources. My 3 resources are install the package, start the service, write the file. So it's installed, it wrote the file, chef client finished, 3 of 3 resources updated. And now I can run kitchen verify. And what you should see is 4 examples with 0 failures. Pretty good? Yeah. You look like you have a question.
Yes, I saw that you write hello with 1 capital letter, but it's not the same output.
Mm-hmm.
So do you
Right.
some
I did that on purpose. I'll show you. Let me show you my recipe again. So my recipe is crazy. I did hello, capital H, lowercase e, capital L, lowercase l, uppercase O. I said hello. But my test expects it to contain hello, but this I at the end here says a case insensitive match, right? So it does match that. That's why I typed it like a crazy person with various cases just to prove that point and prompts that question. So thank you. Yes.
So I ran my recipe.
Yes.
And the last one failed because I accidentally spelled localhost wrong.
Aha.
So I went in and edited the recipe and ran the test suite again without converging.
No.
And it worked.
Yes, because
Why?
where you spelled localhost wrong was not in your recipe, it was in your test.
Oh.
Right? And then you just, yeah,
Okay.
and then you reran your test. Right. So this is the other thing that happens. People write bad tests They fix their tests and then things are green. What you should have done if you were a proper test-driven development fanatic is you should have gone in and commented out that test and then it would have passed. Then it would be ready to ship to production. Of course, that's a joke. Like, don't actually comment out your tests. Fix your test or fix the thing that it's supposed to verify, right?
But so to that point though, we would have to converge before our tests, after any change you make to your recipe, right?
If you make a change to your recipe,
Yeah.
you need to reconverge. If you make a change to your test, when you run Kitchen Verify, so here's the way you remember. When you run Kitchen Verify, it puts your tests into your test kitchen. When you run Kitchen Converge, it puts the things on your run list, so your recipes, into your test kitchen. So in this case, you changed your test. I need to make sure the test gets updated. All you need to run is Kitchen Verify. Yes?
Is there some utility to watch your recipes so that conversions will happen on that?
Right, so you're on a Mac, so I can answer that question with a lot of confidence, yes. So in the Ruby world, there's a gem called guard. And what guard will do is basically look after your file system, and if files on your file system change that match its regular expressions, it will execute arbitrary commands for you. And so there is in addition to the gem guard, there's a gem called Kitchen Guard, such that if you're editing files like in Atom or in Sublime Text, when you save that file that's a recipe or a test, Guard will see that and will actually run like kitchen tests for you. And so, and then you can have it configured with Growl, so you'll get like a little Growl notification that says all your tests are still passing, which is awesome. Now here's another thing that we have to do. If I run kitchen list now, we'll see that the kitchen is there and that its status is verified. This is great, but back to your point from earlier, you mentioned that sometimes when I run Chef on new nodes, the recipe fails. Sometimes when I run that same Chef on a Converge node, it works, right? What we've just done, we've converged a couple of times on this node. So we've run our recipes a number of times. What happens if we start from scratch? So in order to find that out, the next thing we should do is kitchen destroy. Our tests are now passing, everything looks good. So if we kitchen destroy, that will get rid of that kitchen. And then, what do I run to get all the way through to verify? I did create, converge, and then verify, right? Those were the... no, so what you would have to run all three separately, or Test Kitchen is smart. It knows to get to verify, I have to create, and then I have to converge, and then I will verify. So I can skip those first two and just run kitchen verify. You'll see there is no kitchen here. So I'm going to create it, then I'm going to converge it, and then I'm going to verify it. The other thing that you'll see right now is that Docker is beautiful. That create phase, after we created the initial Docker instance, took no time at all. What's taking time now is the converge phase.
Does that only work if it's been destroyed, the kitchen verified?
No. So we could have.
We have to reconverge that and not just.
Oh, right, yes. So if there is no kitchen, you could run kitchen create and then kitchen verify, and it will converge for you. But if the converge has happened ever, and that kitchen exists, it won't run the previous steps. Yeah. So yes, it has to have been destroyed.
So if you have like a CentOS and a Ubuntu and you kill, can you destroy
Yes.
just one of them?
You could write kitchen destroy CentOS, and it would blow away the CentOS one.
And then when you run kitchen verify, it would only rebuild.
And then if you ran kitchen verify, it would verify the Ubuntu, and it would create, converge, and verify the CentOS. Yeah, exactly. Yes?
Is Kitchen aware of Chef policy? So could you like verify in a certain environment?
Okay, so we have this problem at Chef where we created this new thing called policy files, and so that's not what you're asking about.
I mean like Chef environments.
Like Chef environments. So the thing, so the short answer is no, Test Kitchen isn't aware of Chef environments. But the thing that you will put in a Chef environment are attributes. So in your kitchen file, in your suite, you can mock or stub out your attribute values so that you have a known expectation of, I expect that the attribute is going to be this hard-coded value, and let me run a test to validate that. And if what I have in my environments are two different values, what I could create are two different suites that run the same recipes, but with different attribute data. Does that make sense?
Yeah.
Okay, cool. So this is cool. We did a kitchen verify from nothing, and it took 37 seconds for us to create a new image, like create a new Docker instance, install Chef on that, converge, and run our tests. It's pretty cool. One other kitchen command I want to show you is this one, kitchen test. Before you hit enter, it doesn't matter if you hit enter. I'm going to talk about what it does. What kitchen tests will do is look for any existing test kitchens, and it will destroy them. After it has destroyed them, it will create, converge, verify. If all of that works, it will then destroy. So think about putting this into your continuous integration cycle. What I want to do is run test kitchen on my cookbook. If I can create, converge, verify, destroy, I know that this is a good cookbook, and I can push that forward. If you run kitchen test and it does create, converge, verify, if the verify fails, your exit status from running that command will not be 0, so it will not be success. In kitchen test, it will not destroy that kitchen for you. It will leave the broken VM for you so that you can go and inspect it and figure out, like, what's wrong here? What is it, my test? Is it me? Is it you? Like, what's going on? Okay, so I'll run kitchen test here. This is going to destroy, launch, converge, verify.
40 seconds.
40 seconds. So think about this. Think about how is it today in your environment to spin up a new virtual machine, execute your Chef code or your configuration code if you don't use Chef, like configure that machine to be the state that you want it in, and then run your automated tests on that virtual machine. Does it take more than 40 seconds or so for you to do that today? Yes, probably. I hope so. I mean, I don't hope so. Like, I don't want you to be living in a terrible place. But yeah, 40 seconds. We launched a thing. I have great confidence that if I put this in production, it's going to work. Yes.
So when we started writing this test, this integration file was already there.
Yes.
What gives us server spec?
So what?
We generated the Apache cookbook, or?
When we do Chef Generate Cookbook Apache, it gave us that spec file. Yes.
Are there other libraries?
Yes.
Similar?
Yes.
You could set that as the verifier.
Right. So our verifier is server spec today. There are other verifiers that you can use. There's one called BATS. BATS stands for the Bash Automated Test System. So if what we did was write some RSpec and you said, oh, this is clearly Ruby and I'm afraid, what I'm good at is writing shell scripts, BATS is the thing for you. Because you essentially write shell scripts, and if their exit status is 0, that BATS test passed.
Was it back to the default or a while back?
BATS may have been the default a while back. Yeah, I'm not really sure. And then there's also, I think there's that Pester test suite. Anyone heard of Pester? Yeah, a couple of you have. So Pester is a test framework for PowerShell. So if what you don't do is run Windows, I would expect that you haven't heard of Pester. You might like to, never mind. Okay, let's take a break. So I have 2:49, let's take 11 minutes. We'll come back at 3 o'clock. And when we come back at 3 o'clock, we'll play the demo or learn more game again. Sound good? All right, go away. Or stay there, but I'm gonna stop talking for 11 minutes, maybe.
Are you?
I'm at least gonna turn off the mic. Yeah, maybe I'll mute too. me unmute. Let me maybe turn the mic back on too as I talk. So just to be clear, what Chef, like the proper way of running Chef, how that's going to work. What we've been doing is essentially working on a machine, applying some recipes, maybe writing some tests, doing local development. All of that is super important. But the way that Chef works sort of in the real world, once you're in your production environment or even your test environment and so forth, is you're going to have the Chef client running on the nodes within your infrastructure. And what the Chef client is going to do, you're going to have it configured to execute on a regular basis. Now, how regular, that's really up to you. Typically, you'll have Chef client run every 30 minutes. For some of you, 30 minutes may be too frequently. It may be too infrequently. Some customers run it every 5 minutes. But what happens when the Chef client runs is it's going to ask the Chef server, what policy should I follow? I am this node. This is my name. This is my identification. What policy should I follow? Your policy is going to be a run list. The run list is a collection of recipes. So when it goes to the Chef server and asks that question, what policy should I follow? The Chef server has all of the recipes that describe all of the nodes in your infrastructure, or all of the types of nodes in your infrastructure. But you might have a web server and you might have a database server. These are going to have different run lists. You're going to install the MySQL database server on your database server. You're not going to install MySQL server on your web application, but you might install the client there, right? So you're going to have different pieces of your policy that can apply. You can store that in the run list. It's all stored on the Chef server. All of your cookbooks are on the Chef server. When the node asks what policy should I follow, the Chef server has a mapping of your node X, your run list is Y. Here's your run list. And in this particular case, the run list is NTP client, users, and web server. So all of these recipes come down to this node, and then the Chef client will inspect each one of these recipes in turn and apply it to the node. And the order matters. So it will start, in this case, with the NTP client. It will start with the first resource in the client recipe of the NTP cookbook, and it will test and repair. Do I need to do anything with this resource? Yes or no? Do the thing, move on to the next resource. So we'll go through all of the resources in the NTP client, then it will go through all of the resources in the user's default recipe, and then it goes to this thing called a role, and a role is really a collection of recipes. It will go through each one of the recipes in the web server role, and then apply each one of those resources in turn. And what you want to do is have the Chef client run on a regular basis. Here's why. Over time, your policy is going to change. The definition, the configuration that you want set up is going to change. What you don't want to have to do is go out and update each one of the nodes in your infrastructure individually. So you're going to change your policy by writing the Chef code, testing that Chef code, and then publishing that Chef code to your Chef server. And because the Chef client is running on a regular basis, the next time the Chef client checks into the Chef server, it will download the new policy and apply that new policy. So it's very easy for you to distribute policy changes across the entirety of your infrastructure, which is both good and bad. Very easy for you to distribute bad policy changes across the entirety of your infrastructure. So that's why we have things like delivery and testing, that we can validate these things work before we get them into our delivered or production environment. Now, the other reason you want the Chef client running on a regular basis, my policy hasn't changed. Why should I run the Chef client again? That's a real question I would like to answer. Right, maybe there have been some changes on this node that I didn't want. What were to happen if right now, in your text editor on your workstation, you were to open up var HTML, index.html, and change it from hello world to hello surge, like manually change that file. If you refreshed your web page, you'd see the new thing. But is that what you wanted? Probably not. So the next time Chef client runs, it will fix that. It will bring it back in line with policy. The important thing to remember, well, it is important to remember that Chef client is going to run on a regular basis. So when you find that you need to change the configuration of something, that change should always start as a commit into your repository, your source code repository. A commit that has tests that validate that that change is going to do what you expect. Then you actually test that thing before you publish it up to your Chef server. What questions can I answer for you? Yes?
So when you push that bad change out,
Mm-hmm.
how do you undo it?
How do you undo it? You don't undo it. There is no undo. There's no roll back. You roll forward.
How do you force the next fix, not 30 minutes later?
Aha! How do you force the next fix, not 30 minutes later? This is a great question. And there are a couple of ways that you can do that. Why don't I just show you one? And you just asked for one of the things off the demo list. You didn't even know that you asked for it, but we're going to demo it. I'm also going to let you pick something off of the demo list as well. But so the way that you force it, like, so I wrote policy. It was bad. It broke things. Oh, I see what the problem is. I fixed the policy. I republished that to the Chef server. Now all I have to do is wait 30 minutes. Unacceptable. I need to run the Chef client right now to fix this thing, right? So how might you do that? One way that you could do it is you could just run the Chef client manually on those nodes. Also, not so great, because how many nodes do you have? If you have 5 running it manually, maybe not a big deal. If you have 5,000 running it manually on each node, probably not a good thing, like not something you want to do. So there are a couple of ways that you can do this. The way that I will suggest is the best way for you to do it, and the way that you should probably do it today is a thing that I also wanted to demonstrate. So let me show you our list, and I'll take something off of it. So I took Chef Delivery off. You just asked me about remote execution. So how do I go and do a thing on the nodes in my infrastructure? And in order to answer that, I want to come back to this slide for a second. So in addition to storing all of your policy information on the Chef server, the Chef server itself also has a searchable index of information about your infrastructure. So there's an index that I can search to find all of the nodes in my infrastructure in that Chef server. So I'm going to demonstrate some things here. I created all of your machines from my machine using Chef client in local mode, so without a server. But what that means is that my machine has information about all of the machines that make up our lab for today. So if I go over here to some directory that where I am doesn't really matter, one of the things that I can do is I can use knife. I can do a knife node list. So I can list all of the nodes in my infrastructure. And what this is going to do is contact my Chef server and ask, what are all of the nodes that you have available? Except I don't have a Chef server because I used local mode or Chef 0. So I'm going to just pass this -- local. And what this is going to do is it's going to ask my local Chef server, what nodes are there available? So there are a bunch. They're all Surge, their names, node names are Surge group -1, 2, 3, or 4, workstation some number. Now, if I want to run Chef client on all of those nodes, or maybe I want to run Chef client on some of those nodes, I could do that a number of different ways. Let's just, let me just rerun this command, and I'm just gonna do ahead the first 3 lines there and see, like, here's a node. So I'm just going to grab that. And what I can do here with knife is do a knife node show, and then the name of that node. And I want to look at just the local server. Well, what that will show me is that there's this node. Here's its IP address. It's running the recipe Chef Workstation and Surge prepare. So that's how I prepared your laptops, or I'm sorry, your workstations that are up there in the cloud. So this is pretty cool. And I obviously can see the IP address there. Let's see, there's some other information that I can see about each one of those nodes. As an example, I could say, just show me, I don't know, how much memory is available. So let me look at -A for attribute memory, and I can see that that particular node has memory associated with it, right? There's some free memory, there's a total memory, so there's this much memory available on that box. this is all cool. So I can search my infrastructure and find out information about the nodes in my infrastructure. I could run the same thing, or I could do, let me just do a search. Let me do a knife search node. So I'm going to search my Chef server for nodes. I want to find, let's look for all of the nodes. Actually, let's change that so it makes a little bit more sense. Nodes where the name starts with Surge. So any node where the name starts with Surge. And let me look at its platform. What operating systems am I running here? It tells me none because I forgot -- local. So let me run that again. And what we'll see here is that some of these, most of them are running Ubuntu. Some of them failed to be created properly, so they have no platform information associated with them. But so now, onto your question of how do I force a Chef client run? Yes, go ahead.
When you do a knife node show, it queries the Chef server,
Yeah,
but it only knows what the state was the last time the client was node checked in.
that's correct. So when the Chef client runs, let's just come back here to this slide for a second. Chef client runs, this slide is somewhat incomplete. It asks what policies should I follow. It downloads those policies and applies them. And when it's done, it saves the current state of that node back to the Chef server. So now when I'm querying the Chef server, like I'm doing with Knife, I'm getting the same, like the values as of the last time that this Chef client checked in with that Chef server. So if my Chef client isn't checking in with my Chef server at all, and which is exactly the case here with your machines, let me just show you this one really quickly. Let's do the same thing, but instead of looking at platform, and what I'd like you to do is run the command uptime. Your uptime is going to be much different than the uptime that I see. So the uptime I see is 45 seconds, 1 minute and 8 seconds. Like all of these uptimes that I see are fewer than 2 minutes.
So,
Your uptime is much more than 40 some seconds, right? Yes.
will the command fail, it doesn't synchronize, it sends back to the server?
Will the Chef client run fail if it doesn't synchronize its status back to the Chef server? It will, yes. The Chef client will exit with a non-zero status query, yes. Yes. Okay. So this is all cool. We can search about infrastructure, nodes in our infrastructure. I'm going to take another question.
Yes, if the server knows all the web server, for example.
Yes.
Why do I need the client to be running all the time in the machines if I can, for example, when I change something once a week,
Yes.
send notification?
Okay. So here's why. So the question is, if the server knows about all those nodes, like why can't the server just push out changes? Why do I need the Chef client running? Here's, I'm going to give you a couple of answers, or a long-winded answer. I know it shocks you. I have a lot of words to say about this. So first, the way that the Chef client works in its typical operating fashion, it's pull. It's pulling from the Chef server. As it turns out, and there's math and science that can prove this, pull is much more scalable than push, right? And so this is exactly the pattern that we want. And the reason we can't say like, oh, well, just push out from the Chef server once a week. What happens when you push out from the Chef server and 5 of your 5,000 nodes are down or unreachable at that time? It might be 2 weeks now before those things get updated. And 2 weeks later, like who knows what havoc has been written.
It's
Right?
more secure.
Yes. Yes. So you want it to pull, because the other thing that's true about pull is if a server, a client, a node, loses network connectivity to that server, at the 30-minute mark, it's going to fail to connect to that server. At the next 30-minute mark, maybe that has been restored, and it can now bring itself back in line with the policy. But we still haven't answered the question, like, I made a policy change, I just want to run Chef client on that node. So we're going to take what we've just learned about search, or at least what I've just demoed about search, and we're going to use that to implement a push. So from my laptop, I'm going to run knife search node, I want the name to be like Surge dash something, except I know that I had failures in group 4. So I want to not run this on group 4 because it will fail on those. So I'm going to say and not name Surge group 4. I think I was Surge 2015 group 4 star. So any node whose name starts with Surge but does not start with Surge 2015 group 4.
We need extra quotes.
Do I need extra quotes? No, I don't need extra quotes.
But you have a dash after Surge.
Wait, I'm confused. Say that. One person, tell me what I have wrong.
Well, you have Surge dash and then Surge 2015.
Oh, yes. Thank you. I think it should, let's just run that and see. Because I also don't want to actually run a search. Why didn't that work? Because I didn't say local. That looks better. Except there is no 2015. Great. All right, my spot check says that's good. That's Surge group 3 that it's showing, not Surge group 4. So let's say that I want to run a command on all of those machines though. Instead of using knife search node, what I'm going to use is a different command called knife SSH. Now, if I were running Windows nodes, I might use knife WinRM instead of knife SSH. But I want to execute a command on all of those nodes. Now, the command I might want to run is chef client. I'm not going to run chef client because that might destroy some of the work that you've done because my recipes are rude like that. But what I will run is this. Let's do sudo echo I'm going to run this command. What I'd like you to do right now, before I run this command, is check on your workstation, is there a file at /tmp/hi? And if there is, does it say hello Surge in it? There's not, right? Good, because otherwise that would be pretty odd for me. I'm going to run this command, and what this is going to do, knife SSH, it's going to search for all of those nodes. Oh, it doesn't like my, my username and password. There's another thing I need to do here really quickly. Well, I'm going to just do the right thing, which is this. Like, first, I gave you, and I just gave the rest of the world also, your credentials to log into your machines. What you should never do, just to be clear, you should never allow SSH in by username and password. But instead of giving you also some public and private keys when you walk in the door, I run this infrastructure very insecurely. So now that I've streamed this to the YouTubes, all of the people that have been waiting to pwn your machines are thanking me, and your machine is probably gone already. So I'm going to run this now. So what this is doing, knife SSH does a search. Hey, chef server, who are the nodes that meet this criteria? I'm going to then, in parallel, SSH into those nodes and execute this command. So I would do the same thing. I could do knife node, and the search could be at least there's only one that it's asking me for.
That was only that
There.
before you actually did.
Yeah, that one totally failed, but that's cool. Like, it can do that. I don't care. Unless that's yours. Well, in which case, like, you won't have the high.
Oh, that's fine.
Is that yours? Really?
Yeah, at the beginning of the class,
You changed your
I
password.
did.
Yeah, that's the right thing to do. Do you know what I did before class started? I changed my password. So at least one other is going to fail in a similar fashion.
I had too much fun in the public training. That's what everyone.
Yeah, see? He's the asshole. All right, this is like you can check now for temp high. Does anyone have a temp high? I don't know, I don't know the status on where this is, but it's out there. It might be just waiting to fail on another machine. Anyone?
So does that use the private key, the use key, SSH through knife? Does it use or define the private key?
So, yeah, this is a great question. So Knife SSH will use whatever your local SSH config is by default. So I could pass to Knife SSH a -I and a key, just like I would if I were just using regular SSH. If I have some private keys like loaded into my SSH agent, it would just use those. That's why I get too many authentication failures, right? It's trying all of my keys, and it's trying the username and password that I've provided, and then it's just bombing out. Does anyone have theirs yet? Like, there might be too many servers that are in this weird state that I can't actually do the thing. So I'm going to try a different way. I'm going to say, let's just run this on -workstation.
Group dash 2?
Yeah, I think it is group -2. I have no idea if group 2, workstation 1, and 10, and 11, and... All right. So now what I should do is figure out what's the IP address of this guy. Is it you?
Yeah. Let's see.
That's it.
I guess one would get it in.
I don't know why I'm doing that. What I could, yeah. What I should really do is just this. Which group, what, 2? Was that what I did? So now I'm going to search for those same people, and what I'm going to run is cat temp I. I should maybe do that with sudo. I don't know what permissions it has, so I'll just make sure that that's good, and then make sure that I log in properly. And make sure to run the search against my local Chef server. See, it totally works. So what it gives me here in the output is the server's fully qualified domain name, and then the output of running that command. So in all of these nodes, it says hello Surge. So with Knife SSH, what I can do is query my Chef server, find nodes that meet a criteria, SSH into those nodes, and execute an arbitrary command.
Does Chef Client talk to Chef Server over SSH?
No, Chef Client talks to the Chef server over HTTPS.
So what happens if one of your updates breaks SSH?
What happens if one of my bless you, if one of my updates,
Force out updates.
if one of my updates breaks SSH and I want to force a fix, right? So then my next option for Chef has this other component called push jobs. So if I'm running push jobs, it means I have another client on the node. It's the push client. It's basically looking after a queue. It's like RabbitMQ. It's going to pop jobs off of that. So I could put a push job onto that thing, which would fix my SSH config. But the reality is, when you bust your SSH config, it's time to throw away that machine, period, right? So when we used to teach this class, one of the labs that we used to do changed the sudoers file. And so we always had students launch a terminal, log in, sudo to root, minimize that terminal. Now you can continue on with this lab. And inevitably, someone skipped that first part and broke that second part. And what they did was start the day over. Because now your sudo file is completely warped. also could be a problem, right? All right.
And clients are to register themselves to the server?
The clients register themselves to the server, yes. Yes. They absolutely register themselves to the server. Yep. You like, so technically you could create a client object on the server, get its key, and then put that key onto a server that's already there. So then you could, like, in a very pedantic way, say that that client didn't register itself. I registered on behalf of that client. But that's not the typical flow that you'll follow. They'll typically register themselves. Yep. All right. So we got to see remote execution. So now the question is, that was one demo. What you can have now is 2 for the price of 1, or we can just go back to learning. Let me tell you about the things that we're going to learn next, though. We learned server spec tests. The downside of server spec tests were that we had to actually provision a node to run the verification. What if I wanted to verify, so the other question, that was question 2. The third question was, are the resources defined properly? In other words, can I run some unit tests, some tests that run faster, that don't require me to deploy a node? We'll do that with Chef Spec. That's the next thing that we'll learn. And then if there's time at the end, we'll learn about the linting tools, Food Critic and RuboCop. So those are the 3 things left that I want to make sure that I teach you before 5, I think we go to 5 o'clock. We go until you're just done and leave. That's fine. I mean, I'll keep talking until 5 o'clock, as you probably already sussed out. So we have an hour and a half left. We can talk about one of these 4 things. We can talk about these other 3 things that I just mentioned. We can mix it up. So here are 4 things, or we can move on with testing more.
What is Chef Analytics?
What is Chef Analytics? Okay, so the high level is that what Chef Analytics does is it watches after your Chef infrastructure, and it will give you an activity stream of everything that happens there. And there's some reporting capabilities and notification capabilities there. And I can demo all of that for you, or we can learn something else.
Learn some more for now.
Learn some more for now. All right. So also, the rules of that game are the first person to give an answer wins. So if what you were doing was waiting to be polite, you lose. Sorry. That's not always the case, but it was today for that game. So let's talk about Chef Spec. Remember what my first goal was, is that we have fun. So I hope that you're at least doing that. All right.
So is it that we're having fun or you're having fun?
Yeah, you know, like it's, like honestly, the thing is that I have fun. And if you laugh at me, then I think that you're having fun. Let's see, I have to find where I am. I'm totally lost in my slides now. One moment.
You're not gonna do it with a slide anyway.
What's that?
You're not gonna do anything with a slide.
I know, I'm not doing anything with them anyhow. But I just want to remind you that, man, it took us a whole 40 seconds to stand up infrastructure, converge the node, and run those tests. That seems like it took way too long. I want to be able to test faster than that. So that's where Chef Spec is going to come in. And also, apparently when I wrote this, that 40 seconds took about 2 minutes. So we'll definitely get shorter than 2 minutes. I don't know if we'll get shorter than.
Was that with Vagrant?
It might have been with, I don't know. It might have been with Vagrant, yeah. But let's say that we do want, and also think about, like, if you have multiple operating systems, like if you're spinning up a bunch of VMs, those 40 seconds are going to add up. So if we want a faster way, just to like catch a simple typo, something like that, Chef Spec can give us that. So we're going to do just that, catch a typo prior to converge. Chef Spec is another tool that's built on top of RSpec, but whereas Server Spec knows how to talk to servers, Chef Spec understands the language of Chef, and will give you a way to build unit tests around your recipes.
Wait, say that last sentence again.
Yes. What was that? Server Spec understands how to talk to servers, so like we have package and service and port and command. Chef Spec understands how to talk to Chef. It understands the language of Chef resources specifically, so like a cron, a user, a package, a service. Now, because what we've done is a package and a service, like a package is called a package in server spec, and it's called a package in chef spec, and it's called a package in chef. So like it's gonna all just feel very comfortable. So if you go into your Apache cookbook, Chef Repo Cookbooks Apache, you're going to find there's a spec directory, and in that spec directory, you'll find spec unit recipes default _ spec.rb. And that file looks either very similar or identical to this thing that's on the screen. It's at least close enough. And let me just talk through what happens here in this test. We've seen the basic syntax already with server spec, because they both use rspec under the covers. So here's what's going to happen. The first line says requires spec helper. If you look in this path, there's a spec helper.rb that will like load the chef spec library for you. So like you're going to do that in all of your things. We just factor it out into its own file. Then we're going to describe the default recipe for Apache. And then we set up this thing called a context. A context is like, it's part of, or it's like a subset of the describe. It's kind of bigger than an it. You can have multiple its within the context. So we give it a context when all attributes are default on an unspecified platform. So basically by default. And then we have this weird syntax here. Let chef run do and end runner equals chef spec server runner new runner converge describe recipe. What this block of code does is it creates a Ruby variable called chef run. That chef run is essentially converging our described recipe. When your description looks like a recipe, Apache : default, you can use this keyword describe _ recipe. So essentially what's going to happen is the chef client is going to converge that recipe. And then what we're going to do is inspect that recipe through our its. So it converges successfully. I expect the chef run to not raise an error. And here, back to your question of not, how do you do the not? To not. I don't know, yes. So it will not raise an error. But what we want to test are the other things in our recipe. So what other things do we have in our recipe? We have a package in our recipe, right? We want to make sure that it installs the package Apache 2. I'm gonna write some code with you. I'm going to push all the code that I've already written up to GitHub for you. An hour for later or whatever. Okay.
So you're violating your earlier pattern of if it is, don't fail.
Sorry. So, oh, right. So I just wrote the full test instead of just writing the it statement. Yes, because I think we're comfortable with how to write these tests. So I just want to write one and get it out there, and let's run it and see how that goes.
I think you might do that in block. So that's fine.
I'm sorry, what?
For the chef run, I think you would wrap that in a block.
I do not.
You don't?
Hmm. Yeah. So this This thing here, you want that in curly braces? Is that what you're saying?
Right.
Yeah, no, we
Oh,
don't need
because
that.
we're not expecting a raise there.
Right, exactly. And those of you that didn't quite follow that conversation that she and I just had, it's cool, don't worry about it. It was unimportant. It was super important that we both understand what we said, and we do. And if you don't, it's fine.
What if we do have it in curly brackets? So that's okay.
Oh yeah. You do not want it in curly brackets. You want it in parentheses here. Because it's Ruby, so sometimes you'll use curly braces and sometimes you use parentheses and sometimes you use square braces. And it's cool because you know when to use which. Yeah. No, you don't? Oh, it's cool. Just use whatever I use. It's fine.
What does it return? Does it return so it's a chef spec server run instance there?
Yeah, so essentially, like, I'm gonna go way in the weeds for a minute. Okay, you're gonna come with me into the weeds. If what you wanna do is tune me out for a minute, you should maybe do that. So here's the little secret about the way Chef actually works. So I talk about all these resources that we're doing, and it's executing each one of those resources in turn, right? What actually happens is that when you run the Chef client, it runs in 2 phases, which is a lie, but 2 phases is enough for now. It runs in a compile phase and then an execute phase. And what happens in the compile phase is it evaluates and executes all of your recipes, and it builds what we call a resource collection. And so what can happen in your recipes is you could have a Ruby code where maybe you have, let's say you want to install the package that's called NTP and the package that's called Apache 2. You could create an array in Ruby and then do an iterator over that array and then have it say package P and P, where P is whichever thing from that thing. And what that will do during the compile phase is create 2 resources, a resource for them, whatever 2 packages I said. And it will put those onto the resource collection. So the first pass through all of your run lists, it builds a resource collection. And then it takes this resource collection and it executes each one of those resources in turn. That's how it works. With Chef Spec, what happens is we build the resource collection, and then we've sort of monkey patched the execute phase such that every resource has an action of nothing. So it doesn't actually change the running state, but then all of our expectations are written around what does this resource collection contain, right? And so now what we're saying is that this resource collection should contain a resource, a package resource, whose name or package name is Apache 2, whose action is install.
That makes sense.
Totally makes sense, doesn't it? And if what you just got was completely lost, it's okay. But it totally makes sense. Makes sense to you, Adam? Awesome, great.
So there's DSL, the install package is dynamically generated from the action plus the resource thing.
It's this install package is a matcher that is part of the Chef Spec library. And so, remember I said you could create your own resources?
Yeah.
Chef Spec also gives you an easy way to define your own custom matchers. So you can create custom matchers for your custom resources so that you can use them in Chef Spec as well. Yeah. So the short answer is no, it's not dynamically created. It's in the library, right? But you can extend that library. Wow, how about we run this code and see, like, does our test pass here? So I'm gonna quit out of this and show you how to run that code. So I'm in my Apache cookbook, right? I'm in the Apache thing. In this case, actually, I'm just going to show you the safest way to run this. We're going to use Chef, the Chef command line tool. It has a subcommand called exec. We're going to run Chef exec. We're going to use rspec to run our spec tests. That's the minimum that we need, but I'm going to give you some more flags to throw in there. So Chef exec rspec against the spec directory. What doing this will do is it will look in the spec directory and all of its subdirectories, and any file that ends in _spec.rb, rspec will execute those files. But I want to make a couple of changes. The first change I want to change is the format of the output. So I'm going to do a -f, and I want it to be like documentation. So it's going to be -fd for documentation. And then I'm going to pass a -C because I want the output to be colored, because I'm a human, not a computer, and I prefer colors. And then I'm going to hit enter. And what you can do is you can turn on and off those flags and see the differences with and without them. But this looks very much like the server spec output that we saw, but it ran much faster, 3 seconds instead of 40 seconds. That's, you know, I don't know, about the order of magnitude faster, if the math is about right. But it converted successfully. It installs Apache. Both of these are working. So what I'd like you to do is,
Sorry, can you help me understand what exactly that's doing? RSpec is running on the local workstation there?
yes.
And is it connecting to your vagrant?
No, it has nothing to do with that. There's no infrastructure that got converged when I ran that. I don't have to run a converge anything. I just, essentially, what I'm doing is a unit test on that recipe. So I basically take that recipe, load it into memory, and then I inspect that recipe. It's essentially what I'm doing, which is what I said about 10 minutes ago, but I used 10 minutes to explain. I'm taking that recipe, loading it in memory, and then testing that recipe, making assertions about that recipe. Yeah? So what if let's make a test to make sure that the service is running also. And what we test there I'm only going to give you the end. I'm not going to tell you the other part. Like, what do we expect? I basically gave you the answer without giving you the whole answer, but what should I type at the beginning of this line?
Speak it or?
Yes, you can tell me what to type here.
The exact same thing, expect, quote, or whatever.
Right. With Chef spec, the expectations that we're setting are always on the chef run. I expect the chef run. I expect the recipe to include this thing. It's going to be start_service is the matcher that we're going to use, and then Apache 2. Another thing that we might do, and let's just go ahead and do this because it makes sense to do so. It enables so I want it to enable Apache to start on reboot. Let's do that. We'll do 3 tests here. One to make sure that Apache 2 is installed, one to make sure that the service is started, and one to make sure that the service is enabled. Only 2 of these tests will pass. Which 2? The first 2, right. And actually there are 4 tests, so it'll be the first 3 that pass. All right, I'm gonna go ahead and run mine. And just because I'll turn off those flags, I'll just run chef exec rspec spec, and we can see the difference. So the difference, well, of course it fails, so that's a difference. But when you run it without those flags, it just writes out a period for each one of the tests that pass. And it doesn't give you the full like documentation of these are all the things that pass. It only shows you the things that fail. So it says I expected a service named Apache 2 to include this action of enable. So let's go ahead and change our recipe so that it does that. Now there's 2 ways that we could do it. There's the wrong way and there's the right way. I'm gonna do it the wrong way first. So now I have service Apache 2 with an action of start and service Apache 2 with an action of enable. This is in my recipe. And if I run my unit tests here, it works. 4 examples, 0 failures, but I got a bunch of warnings. I don't like those warnings. Let me show you a different way to write that. Here we have the same service, Apache 2, with 2 different actions. Instead of specifying a singular action here, I can create an array of actions. And an array in Ruby is going to be in square braces with values separated by a comma. So here I have service Apache 2 actions start and enable. And now if I run my chef spec, I suspect it won't throw those warnings and everything will pass. And that's the case. So everything works, everything's good. What questions can I answer for you about chef spec? Yes.
So I'm getting a number of odd errors about from file.
About from file.
I get warning resource.
Yes, that's the same thing that I just had, right? Not just here, but back when your recipe looks like this. No? Okay. I'm gonna come look at your thing. But that's so. Thanks, Sam. So this is where I got some warnings, but maybe yours are different. So we'll look at, but it feels the same. It looks the same from here. I don't know. Is that a hand raise or just a stretch? Yes. No examples found. Okay. So what's your PWD? That's the first question. If you're in the right place. Aha. That would totally do it. Because you don't have a spec subdirectory in recipes.
Right. Does order matter within the array of actions?
Does order matter within the array of actions? This is such a brilliant question. You don't understand how much I wanted someone to ask that question. It's so
He
lucky.
does it for this moment. I've had to do this a couple of times. Preparing yourself.
Okay, so first let me change my thing so that it does the right thing here. And all that out. Okay, so the question is, does order matter? Why don't I do this also just for because, so that it's very clear what we're doing. I'm not going to leave them both in there, but the question is, are these two things the same, right? Does order matter? So what happens with Chef, as it's executing this, it is going to execute them in the order in which they are listed. So in this scenario, the first thing it will do is start Apache, and then it will enable Apache. In this scenario, the first thing it will do is enable Apache, and the second thing it will do is start Apache. So Chef cares about the order, and it's going to do the things in the order in which you define. But that wasn't the question you asked. Does the order matter? Was the question you asked. You thought you were asking the question that I just answered, but this is why I love that question. So I'm going to ask you, does it matter which order these are in?
Probably not for that resource.
Probably not for that resource. Would you agree or disagree? Somebody agree, somebody disagree, please. All right, so here's the thing. Has anyone ever written a configuration file for a service put that service into check config so that it's enabled on reboot, but your configuration for that service was borked. And then you rebooted that machine. What happens? The machine could hang trying to bring up that service that's enabled, and you could be in a world of hurt. So, from a Chef perspective, nope, order doesn't matter. From this resource perspective on the surface, nope, order doesn't matter. But what will happen if you have a worked up configuration and you tell Chef to start it, the start will fail. And it will stop there, and it will never get to the enable. So, the right answer to your question is, yep, order matters. Start things before you enable them, but it takes a little bit of explaining. Thank you for asking that question. I will tell Rana that you are the best student in the class. Is that twice I said it for you?
It is.
Okay, but you moved chairs. You were sitting in the other chair earlier? Yeah, that's why I'm confused. All right. Also, you two are basically twins. So, okay. What other questions can I answer for you? Yes.
How do you plug in like configuration parameters into your resources?
How do you plug in configuration parameters into your resources?
Like you don't want to build a resource that hard code ports and things.
Yes, you definitely don't want to do that.
So
Right. Okay. Let's change. Let's do that by writing some code. Oh, let me fix my code here first. All right. We're going to do this in a very simple way. So the question is, how do I inject some configuration parameters into my things? Because I'm not going to hard code values into my configuration files. I don't have a configuration file that we can easily play with, but what I do have is our homepage that we can play with. So even if we inject some configuration parameters into our homepage, it's not really going to change, but it will demonstrate the capabilities, right? So there's two ways that, well, there's a couple of things that we can do. So let's go back into our recipes default.rb. You can do this or not, it's in the slides. And instead of using a file resource, what we're going to use here is a template resource. And then with a template, instead of content, we're going to specify a source. And our source is going to be an ERB file. I'm changing my template to var my file from a file resource to a template resource. And instead of content, I'm going to specify a source attribute, index.html.erb.
does that file exist? Or
Mm-mm. Not yet. We're going to create that file next.
Okay.
Everyone have this? Can I leave this screen? I'll give you another 30 seconds or so.
Is ERB like a naming convention?
ERB is not, no, it's not a naming convention. ERB stands for Embedded Ruby.
Okay.
Also a lie, but it's close enough to the truth that it's good. Embedded Ruby is what we're going to write. So, okay, everybody has this. The thing that we need to do now is go and create that index.html.erb file. And what we're going to do to create that is we're going to use Chef to create that. So Chef generate has a command called template. So we can generate a Chef template. When you generate a Chef template, you have to tell it which cookbook do you want to put that template into. And the way you tell it which cookbook to put it into is you provide the path for the cookbook where you want that template to go. I currently am in the cookbook where I want that template to exist. So my path is dot. And you give it the name of the template that you want. And I'm going to call mine index.html. Now, we called it index.html.erb as our source. Chef will automatically append the .erb extension to us to this file name if we don't provide an extension of .erb. If I typed in here index.html.erb, Chef will not add another .erb extension. So it does the right thing for us, which is really nice. So I'm going to do that. It's going to run a little Chef recipe in the background and create that thing. And what you'll see is that it creates that file in this path, templates, default, index.html.erb. There was another thing that I should have done that would have been cool to see, but it's in the slide. So what you should do is work through those things. Yes. So what is our index.html.erb .erb look like? It says hello world. And let's say, I'm just going to type and then I'll describe what I'm doing here. Okay. Hopefully you've typed this, otherwise you can listen while I speak. You're ready to finish typing it. So index.html.erb. ERB stands for embedded Ruby. So I can embed Ruby into this file. There are two ways that I can embed Ruby into this file. I'm only showing you one at the moment. So the first way that I can embed it is I want to interpolate some values, or I want to do some variable replacement. So when I do that, I write down this angry squid, or a less than % equals, and then the variable whose value I want to inject into this template. So the variable, remember when we did the knife node show and we saw like the memory for that node? Node available to us is basically a data structure that's available to us in our templates as well as in our recipes. And each one of those attributes that was in that like chain is available as a key. So there was a memory key and it had a sub key of total. So what this is going to do, oh, and then I close off my variable replacement with a % greater than. So this is going to say I have some amount of memory RAM. So I'm going to write and quit this file. And then before we execute this, I just want to tell you where that data comes from. Chef gets that data from a little application that's part of Chef or installed with Chef called Ohai. So if you run this command on your workstation, Ohai, O-H-A-I, what you'll see is this huge, massive JSON-looking document that has all of this detail about your system. So Ohai is a system profiler. I can run Ohai memory, and it will show me all of those keys available in memory and then the values for each one of them.
Is Ohai connecting to the Chef server to get that?
It is not connecting to the Chef server. Ohai is looking in, it's inspecting this system on which it's running. But this Ohai data is what gets reported back to the Chef server, right? And so if I wanted to see with Ohai just the memory total, I could run Ohai memory. Ohai at the command line, the way you step through those keys is with a slash, so memory slash total. And that will show me here's the total memory. So this is what I expect to show up in my homepage when I execute that. So we haven't done this yet. We should probably apply this cookbook. Let's go back, let's go ahead and do that. So I'd like you to be in your Chef repo. So you're at home, Chef repo. We're gonna run sudo chef-client. We're gonna run it in local mode. So you can run local mode one of two ways. You can use -z, or you can type in --local, whichever you prefer. -z stands for Chef 0. And if you remember from your kitchen YAML, we called it Chef 0. Chef 0 or Chef Client local mode, you're saying the same words. You're saying the same, you have the same meaning, basically synonyms. And then we need to specify a run list, so a -r or --run_list. And then our run list is going to be recipe, and then square brace Apache. You have one of two ways of doing this. You can just say recipe Apache, or you can do it like every other tool that we've seen, like in Test Kitchen and in Server Spec and in Chef Spec. You can say recipe Apache :default. So this is really like a naming convention. When you give it a recipe in your run list, you're going to name the cookbook, and then the name of your recipe file. If you leave off the name of your recipe, Chef will assume that you want the default.rb recipe. So saying recipe open bracket Apache close square bracket is the same as recipe Apache : default. So now if I run this, what we should see is that our index.html changes, and we now have the line that states how much memory I have available. So the way that you can inject configuration values is by pulling data out of your node object. The data that's in your node object by default is going to be OHI data. But what if you wanted to inject your own data into the node object? Let's do this. Go back into Cookbooks, Apache, Recipes, Default. It's not there. Let's go back into, you should always do what I mean, not what I say, or necessarily what I type either. Recipes, so Cookbooks, Apache, templates, default, index.html.erb. Let's say that instead of saying hello to the world, I want that to be variable. And instead of world, what I want to do is pull from the node. I want to pull a thing that's called Apache greeting. So we're accessing it as a node attribute, just like we did with data from OHI. All right, and quit that. We're looking for the Apache greeting. Now remember, if I ran OHI memory, it showed me the memory values. If I run OHI Apache, I throw an error. There is no Apache attribute that OHI can return for me. So what I'm going to do next is, again, use Chef to generate an attribute. That attribute is going to go into Cookbooks Apache. We're going to call that attribute default. So we're going to create some default attributes for the Apache cookbook. So it's Chef, from your Chef repo directory, Chef generate attribute. For which cookbook is this attribute? It's for the cookbook in Cookbooks Apache. And what do you want to name this attribute? I'll call this attribute default. So that's going to run, again, some more Chef, and it creates this file that I'm now going to open, Cookbooks Apache attributes default. Here I'm going to define a default value for Apache greeting, and I'm going to set that to Surge. This should look not dissimilar to what we saw when I did the delivery demo, where we had hello chef friends or welcome chef friends or whatever it said, and we had some value for that attribute. Also, I used double quotes there, and it doesn't really matter. So now, if I rerun my chef client, so chef client -- local or -z -r recipe Apache default, we'll see that it changes from hello world to hello surge. I lost you.
Yeah, well, what was that last command? It was Chef.
Chef -client -z -r. You should have it in your history.
Yeah.
It's probably through 4 up arrows. So here's what you can do. In your cookbooks, you can create new attributes. And you can use those attributes in your cookbooks, either in templates, like for configuration files. You could also use those attributes for some control logic in your recipes. Like you have those attributes available, and you can make business or logic decisions based on those. You can also use the attributes from OHI. Now, when you put the attribute in a cookbook, so it's an attribute that you defined, Chef gives you the ability to override the value of that attribute based on the environment that you're in. So if in my dev environment, the attribute value is X, but in my production environment, the attribute value is Y. So in the environments file, which we don't have time to look at, you can model that within Chef. You can use these attributes to really keep your policy as generic as possible. So let's say that you want to set up shared memory, like some system parameters, kernel parameters on your system, where shared memory gets 80% of the memory that's available, because this is going to be a database server. Well, I can write a recipe that does math, like it inspects how much memory is available on this machine, allocate 80% of it to this particular field, this particular setting. And then I can take that same recipe and run it on my laptop, run it on a machine with 128 gig of RAM, run it on a machine with 256 gigabyte RAM. And you're going to get the same result in either place, or not the same result. You're going to get the appropriate result in all of those places. So you can use this data, inject a little bit of data, have dramatic change on the policy. Yes?
Can we get those into the test?
Can you get those into the test? Yes, you can get those into the tests in a couple of different ways. So let's start by talking about, we'll talk about it in the same order that we introduced them. Let's talk about the integration test first. Let's go into QuickBooks Apache, and let's open up our kitchen.yaml. Go down to the bottom here, you'll see that there's an attributes key that's empty. What we're going to do in attributes, we can say Apache default Apache greeting. Set that to world. Now that syntax might be off a little bit because it's YAML and I don't really know what I'm doing when I write YAML, but it looks something like that. It's easy enough to test. We can just do like a kitchen list. I'll put that back up because you probably didn't type it yet. Let me change my test also instead of hello. I'm going to change that to world, right? And then I'll just run a kitchen verify. And it totally failed. Why did it fail? Failed to, oh, it doesn't like, okay. It doesn't like my kitchen YAML. Yeah. It should look like that, I think. Don't quote me until it like works successfully. Nope, not like that either. No dashes at all. See how easy it is? I'll put it back up as soon as it's done, but this will pass the verify. So while the busser is running, never mind.
So, anybody use these resources, have access to the internet?
Yes. So let me first put this back up and then I'll answer that question. So here's how we added those attributes to our test. The other thing that we can do that I won't show you, but you can check the docs for, is if you want to add those attributes to unit tests, when you create that chef runner, there's a way to describe which attribute values you want for that chef runner. In that let chef run block, you would define those attributes. And chef spec documentation is pretty good about showing you how to do that. So your question was, great, but I work in an environment that can't talk to the internet. What do I do? Right? Because clearly we're talking to other services in the internet here to go and grab packages? And the short answer is you do the same things that you do to run your operational environment right now, right? So you probably have some package repos that are mirrors from the internet. You take the Chef package, the Chef client package, and you put it into that package repo, and you configure your servers to talk to that so that it can grab the Chef client from there. You configure it such, like in this particular case, Test Kitchen just downloaded Busser from the, or sorry, the Busser just downloaded server spec from the internet. Wherever you're running that Test Kitchen, it should be pointing at a gem source that it can actually access that should have those server spec gems installed on it. So yes, there's a lot more configuration like planning that you have to do up front, but also, one might argue, you're running a more professional environment because what you aren't doing is going out to the web and just grabbing the latest version of whatever package it is that you need. Can totally be exciting, yeah, yes. Sometimes in a not very good way at all, right? In fact, when it is exciting, it's because it's not good. Okay, I want to ask a couple of questions now, though, about these two different test frameworks. Because what we did was look at server spec, and we looked at Chef spec. So here are my questions. In Chef spec, well, in server spec, one of the things that we did was validate that the server was listening on port 80. How do you do that in Chef spec? You don't. You can't. Because we aren't actually converging the node. We cannot assert that that port is listening. It's a test that's only available to us after we've converged a node or on real infrastructure. Remember, with Chef spec, we're basically just working in memory. There aren't ports listening in memory. But then my other question to you is, knowing what we know now about unit tests through Chef spec and the integration tests through server spec, we go back and look at our server spec tests. The three server spec tests that we wrote, are there any here that you might get rid of now that we have unit testing also?
Well, the homepage says hello.
Yeah, so the homepage, I mean, my description there changed, it should say world, right? This thing, you can't actually run as part of your unit test. So it has to be in server spec. If this succeeds, we know that the service must be running. And frankly, do we care if it's Apache or if it's Nginx? Not once the node is converged, what we care about is that it says world. So we can get rid of that test. We can't get rid of the port test. We can't get rid of this curl test. These are valid tests to have here. The other thing that's true is, what if this cookbook were targeting CentOS and Ubuntu? I would have to change my integration test for the name of the service. That feels like a thing I should do in my unit testing. Because what's the service name on CentOS? It's called HTTPD. And the package name is HTTPD. But on Ubuntu, it's Apache 2. So what I really want to do is test those level of changes, those platform differences, in my unit test framework, and test the end result, the running environment, in my server spec or my integration test. Did you have a question?
I was just going to say, if you're using curl to the default port, wouldn't be listening on port 80?
This is a very good point, yes. So if I'm curling to HTTP localhost, clearly something's listening on port 80. Or if I did to localhost :8081, I wouldn't really need a test for port 8081. That's absolutely true. Yeah. All right. We are now at 4:16. So what I would recommend that we do, here's what I'm going to suggest. The first thing I'm going to do is push all of the code that I've written up to GitHub. Now you have all of that code that I've written is available to you. So for the last, we're now down to like 40 minutes or so. First, you have all of the slides, all of the code from everything that we talked about today and more. So there were some labs that we skipped in there, but I think the slides are pretty good in terms of walking you through. They're not nearly as funny as I am, or at least they're not as funny as I think I am. So, you know, they're kind of dry, but it's cool. You can learn from them pretty well. What I would like to do in the last 40 minutes, is you can pick from this list of 5 things. Actually, there's 6 things. So you can do one of these 6 things for the next 40 minutes or so. But before I let you pick, I want to say a couple of words. I want to thank you for coming today. I hope that this was a good way to start Surge for you and give you like a little bit of thing to learn, maybe hopefully a little bit of fun across the day. I hope it was worth your time. I know that Surge is a mediumly priced conference. It's not inexpensive, it's not a super expensive. But with any conference, I find that the real investment is not the price that you pay for the ticket, but it's the investment in time that you make. Because this is time that you've spent away from your day job, if you will. I personally think it's a wise investment, and I hope that you're walking out of this room today feeling like you made a good investment in yourself across the day. And hopefully I will see you around Surge for the next 2 days. Both myself and a bunch of other chef people will be at the chef booth in the expo hall, so you can find us and ask us any questions that you want about chef. If there are demos that you want to see, we can show you at least the demo things that are on this list then, and maybe other things, and answer whatever questions you have whatsoever. I think Surge will send out a feedback survey at the end of the conference. If they do, I'm sure they will. If they include questions about this day, what I would love for you to do is be as honest as possible. Like, share with us what you actually felt about today, because that helps us get better. With that, thank you all for coming. And with the remaining time that we have together, the next 40 minutes or so, these are your choices. So I'm going to stop talking and listen for a choice. Yes?
I'm going to ask, why is Chef and VMware up there? It seems like an odd, you know, you don't have Chef and AWS.
Oh, so the reason we have Chef and VMware up there is because Adam is on our partner engineering team and does a lot of integration with VMware, and he's here and can demo Chef and VMware. We can totally talk about Chef and AWS. Here's the thing, like, so honestly, the other reason is because I never do VMware, so I can never talk about it, and so it's kind of special that Adam is here and he can talk about Chef and VMware. So if you use VMware, you should ask for that. But if you don't, then it's cool.
Can you contrast or compare it to Puppet? Why might one choose one of them?
Yes, sure. You mean in a way that's not as like ridiculous as the keyword that they selected, action over ensure? Oh, okay.
That's the most important thing.
That is the most important thing. Like that's the reason why. No. So here are the differences between the two. When it comes down to it, if the question you ask me is should I use Chef or Puppet, or if the question is should I use Chef or Puppet or Ansible or Salt, my answer to you is yes, you absolutely should. The thing that you should not do is do this by hand. The thing that you should not do is roll your own solution to solve for this. But that's not what you asked me. Like, but why would I use one over the other? At a very high level, all of these tools are after solving the same problem, solving for the same thing, right? What we want to do is help you automate your environment. There are some technical choices that are very different across the different tools. One of the starkest examples of those differences is if you look at, say, Chef or Puppet and Ansible or Salt. Chef and Puppet work in this pull mode. Ansible is definitely a push mode. You push from your workstation, you push changes out to your infrastructure. So push versus pull is a big difference. Now we saw with Chef today that with Chef I can actually do push or pull. The default mode is going to be pull, which is the right, like, scalable, safe way to do things. So that's one difference, push versus pull. Another difference specifically, well, really with all of them, Puppet gives you a Puppet language. So you have a domain-specific language, that's Puppet. When you sit down to write Puppet, what you're writing is Puppet. When you sit down to write Chef, what you're writing is Ruby. We tell you it's Chef, and it's Chef, but it's Chef that sits on top of Ruby. And when you need to write Ruby, you just write Ruby in your recipes. So you have the full programming language at your fingertips. Now, there are positives and negatives to having a full programming language at your fingertips. The positive is you can basically do whatever you need to do. So as your infrastructure gets more complex, as the requirements that you have get more complex, you have better tools available at your fingertips. The problem is you can write really complex stuff. You could shoot yourself in the foot with complexity by writing a bunch of Ruby into your chef recipes. So with Puppet, you're more constrained because you have to write in there DSL. Now, Puppet is an extensible framework, just like Chef is an extensible framework. When you start extending Puppet, it's going to feel very different than when you're writing like regular Puppet. When you start extending Chef, what you're going to do is just write more Ruby, so it's going to feel similar. The other thing that's true that is a huge difference between Chef and all of the rest is that the tooling in the ecosystem, especially around test-driven development, some of the stuff that we looked at today, is far and away better in Chef than it is in any of the other tools that are out there. Part of that has to do, going back to that domain-specific language, with the fact that what we're writing is Ruby. There's a couple of things about, first, it's like super extensible, it's a fun language to write in, but also sort of the community of Ruby. When you learn Ruby, typically, the thing you learn to do first is write a test. Like, so Ruby has a foundation in this idea of test-driven development. And so Chef really mirrors that community ethos of what we do is we write tests. Now, the other things that I think help differentiate Chef, when you start to look at things like analytics, which we haven't really looked at, we talked a little bit about. You'll find some of those capabilities in Puppet as well. But when you start to look at audit mode, which we haven't looked at, but let me just show you a quick thing with audit mode. It's on the list, so I'm just going to show it to you. And I actually gave it to you. You can run this right now yourself. So in your home directory, there's this thing called cookbooks. In that, there's a cookbook called Audit Shell Shock. Let's just look at that really quickly. So on your workstation, I'm in Home Chef Cookbooks, Audit Shell Shock. Here there is a .kitchen.yaml. So I want to open up that first. I want to look at a couple of things. So at the top of the file, the driver is the same as what we set up. It's a Docker driver, use sudo as false. The provisioner is chef 0, but we're going to change the client.rb, so the chef 0 configuration. And what we're going to do is we're going to take what we call audit mode and turn it on. So audit mode is enabled. And then what I have for my platforms, I'm actually using an older version of CentOS. So I'm going to use CentOS 5, version 5.11. And then my suite, I'm going to run this recipe called Audit Shell Shock Default. Okay, so what I'm doing, if I were to run, and don't run this yet, because I want to look at the code, but if I were to run Kitchen Converge, it would launch a CentOS 5.11 server for me in a Docker container. And then it would run my Audit Shell Shock, and it would include the audit mode. Let's just look at that recipe. What you'll see in this recipe is something that looks a little bit different than what we've seen with our other resources. Instead of resources, this is a recipe that's full of audit controls. So we have this block called a control group. A control group is almost like your describe in a server spec test. So there's a control group called Shell Shock, and then within Shell Shock there are a bunch of controls. And not surprisingly, this looks very much like the server spec stuff that we wrote earlier. It's not surprising because the underlying mechanism for audit mode, the underlying language, is server spec. So what I'm writing here are tests, expectations in server spec that validate that shell shock has been remediated. This server is not vulnerable to shell shock. Now you can write all kinds of tests, all kinds of controls. And what will happen is that the Chef client will run, and after the Chef client has converged the node, it will then look at your run list for any control groups and execute all of the control groups and report back the status. So here, if I just quit out of this, you may have already done this because you may be worked ahead. It's cool if you have or not. If I run a kitchen converge, this is going to spawn that CentOS 5.11 server. It's going to converge my resources, and my resources, there are no resources in my cookbook. So it says here, converging 0 resources. And then it's going to run the audit phase. It's going to audit this server. And it's going to find that a bunch of my tests, 5 of those tests failed. So shell shock, depending on how you tested for it, you might consider it remediated, but there are a bunch of different ways that you could exploit the shell shock vulnerability. So we can see here exactly which pieces are failing. So the nice thing about this is I can now, as I want to come in line with my policy, my compliance, my regulations, with vulnerability checks, the way that it works in the past is a new vulnerability is announced. I have to run a scanner against my environment to see, am I vulnerable to that thing? Well, now with audit mode, what I can do is I can write those scans, those tests, directly into my code, so that as I'm building my cookbook, I can immediately start auditing that infrastructure before I put it into production. And then likewise, because the Chef client runs on a regular basis, it can run those controls for me every 30 minutes, and it can test, am I compliant with PCI? Am I vulnerable to shell shock? And so when it finds those vulnerabilities, it can alert you to them, and that's where Chef Analytics kind of comes in matched up with this. Chef Analytics can see audit mode failed. I'm going to fire off an alert to someone and say, hey, this node is now vulnerable, or this thing is out of compliance. Yes?
Is there any public research where you can find this, like a definition of all this?
Yes, so that's also a great question. On the supermarket, if you go over here to supermarket.chef.io, you will find, I'm just going to search for audit. There are 3 cookbooks right now. The one that I wanted to show you was the Audit CIS cookbook, though. So Audit CIS is the Center for Internet Security. The Center for Internet Security publishes a bunch of benchmarks. Now, I should state, this cookbook is not supported or endorsed by the Center for Internet Security or its affiliates. Okay. Now that that's been said, we can look at the source for this cookbook, and you'll see that this, in the recipes, there are recipes for various, you can't see that, a little better, for various operating systems. So for example, if we look at CentOS 7, you'll see that there's a control group and then hundreds of controls in here that implement the Audit CIS cookbook. That implement the Audit CIS controls, right? So what I could do, I could easily just clone this repository. Might as well just do it.
There's another resource called OpenStack.
Yes.
OpenStack is also another resource.
Yes, open SCAP. Yep, SCAP, open SCAP. So here I usually run this with Vagrant, and as you saw, it's configured to run with Vagrant. I don't know if it's going to work with Docker or not, but why don't I just try Kitchen Converge? I think there was only one on Ubuntu. Yeah. So Kitchen Converge Ubuntu. You only need enough to uniquely identify that instance. So I could have just typed Kitchen Converge U, because there is no U in CentOS any version number, right? So it just looks for the thing that matches. And sometimes it needs one thing to match, sometimes it can match. Like I could do like Kitchen Converge C, and it would converge both of the CentOS instances, but not the Ubuntu one. I don't know what this is going to do. One of the things that Test Kitchen had said though was that audit mode was in audit only. So when the Chef client runs, it won't change anything. All it will do is run those controls. And so it failed. I'm sure it failed because controls failed. So 124 of 215 controls succeeded. So this is the whatever base thing I get from Docker. When I start with that one, it is not following the CIS. But like, don't say, oh, well, of course I will never use Docker because it's clearly insecure. If you run this cookbook on anything in your infrastructure, unless you've like explicitly gone out and set to remediate against all of these things, you'll probably have some failures also.
And for intrusion detection, where
Yep.
permissions, volume set the right way.
Exactly.
There's that whole
Yeah. It is very extensive, right?
If you actually follow all those things, you have a break.
Yes. It's right. Very true. So, so I think that this idea of building audits, building these control groups into your development cycle changes the way you think about how you run more secure infrastructure faster. Before the days of automation, or as automation was new, your chief security officer is likely to say, no automation. I only trust it if a person does it, which is a ridiculous thing to say, but it can be difficult to prove that to a security officer. But then something like shell shock happens, and with Chef, you write a recipe and you remediate shell shock very, very quickly. Now the security officer can understand that we can remediate problems very fast. But layer on top of that, this idea that we can also audit for those problems. I could write a control for shell shock, run Chef client across my entire infrastructure in audit mode only, and it will immediately tell me which nodes in my infrastructure are vulnerable. And then I could write a recipe to remediate that. So on your workstation, if you want, for that CentOS 5 where the audits failed for shell shock, it's easy to fix if you create a package resource whose name is bash, and action is upgrade. And then rerun Chef Converge. It will upgrade your bash package, and then it will run your audits, and you'll see that you're now compliant. So you can see that whole like cycle. The other thing that's true is that the instructors who teach you Chef are far more humorous and fun to hang out with than those that teach you Puppet or Ansible or Salt or whatever. So, I mean, that's definitely a criteria for making that determination. Also, you're a Ruby developer, right? Mm-hmm. Yeah. So it's pretty obvious. Like, use Chef. It's the thing you want to do.
That's a helpful.
Okay, cool. And lucky for you, it's all on video. Right? You get it going. Like, just hit play. Awesome. All right, so we still have, 25 minutes. I'm going to take audit mode off of the list now.
analytics we're looking for.
Chef Analytics is one of those premium features. But the thing I didn't tell you about the premium features, also because it's not true for delivery, maybe that's why I didn't mention it. But for the premium features, with Chef Premium features, excluding delivery, if what you're managing is fewer than 25 nodes, it's free to use, right? So even the premium features you can use for free if your infrastructure is small. When you get above 25 nodes, then you should talk to us about maybe sharing some money with us. And we'd love to help you stay successful. And yeah, so we'll do that.
And that's only when it's hosted, right?
No. Chef Analytics is a premium feature. Chef Analytics is actually not available as part of hosted Chef. Chef Analytics you will install on your own premise. And by on your own premise, I mean there's also this thing with AWS, back to why isn't AWS on this list. In the AWS marketplace, you can actually launch a Chef AMI, and that Chef AMI has all of the premium features minus delivery installed on it. So it has analytics installed on it already. It has the web user interface. It has all of that stuff ready to go. And the cool thing about it is you can buy, like you can run from the marketplace an AMI that has a license for 5 nodes. That's all free. For 25 nodes, free. For 100 nodes, now you just pay a little bit more for the AMI. You don't have to talk to us. You just run that AMI yourself. And if Amazon, like AWS, isn't your jam, we have the same thing in Azure. If neither of those are your jam, like it's pretty easy to stand it up yourself also.
And the whole delivery thing is a whole different model and so forth.
Yes, delivery is it's a brand new offering from us. It is, you pay for it separately, it's priced differently. And if you want to know how it's priced, the answer is we will talk to you about how it's priced. Most of the premium features, I can stand here and tell you right now that for your premium features, you pay a subscription basis, and it's based on the number of nodes that you're managing. Delivery is not that, and delivery requires a conversation with you to understand how we should price it for you, like what makes sense for all of us.
So is Jez Humble pretty involved in the development of that, or?
Yeah, so Jez Humble joined Chef as delivery was sort of reaching the end of its beta. So the short answer is no, Jez was not heavily involved in the development of that. That said, as it turns out, Jez Humble is pretty influential in the way that people think about continuous delivery. So while he might not have been involved in the development of it directly, he was definitely, we definitely followed patterns that he's described pretty well.
Could you talk about policy files for a few minutes?
Could I talk about policy files for a few minutes? No, but Adam can.
Sure.
Awesome.
Why not?
It's not because I don't love you.
Can you hear me? Can I plug
Yeah,
in?
you can totally plug in. Except if you're on the stream, you won't get to see Adam, sorry. You can listen to him.
Sweet. That went really well.
That went well, didn't it?
All right, give me just a minute to get set up here, and while I'm doing that, I will talk about policy files and what they are and why you would want to use them. Okay, so as Nathan was describing earlier, the Chef server stores information. I'll be honest, it's a glorified artifact server, right? It knows about stuff that you've given it. It knows about your cookbooks and your recipes. It knows about the nodes that are registered to it and all that other fun stuff, which is great. A Chef client talks to the Chef server, pulls stuff it needs, blah, blah, blah. So what are some of those artifacts that you care about? The recipes you just authored are in cookbooks, and then the nodes themselves have information about them. Let's see if I can make this bigger. I can't even see the screen. Okay. Really? Seriously? Okay, how about that? So if I do, I'm just going to do a knife node edit on a host that I created the other night. And it's going to, if this works well, come up with a little editor, come up here. Of course, why wouldn't I have that set properly? So outside of the policy file world, when you go and create your node, register to the Chef server, and tell your server to do something, this is the very thing you're going to do. You're going to type knife node edit my node name, and you're going to populate this little JSON block with information that you want that node to do. Very specifically, that run list, right? So when we were talking about Chef apply, you passed it a recipe. When we were doing Chef client local node, you passed the -r with the run list. But this is how you actually put that information on the server. So in this run list, I might put a couple of recipes in there that, or a role, which is like Nathan said, a collection of recipes, and that's all fine and good. For those recipes to function, certain things have to be true. For example, if I put a run list in here that says recipe Adam is awesome, no really, guess what? This is going to save totally fine back to the Chef server, but when my node Surge Demo 1 connects in, Chef client's going to unwind. It's going to blow up because I've never created the Adam is awesome cookbook with a no really recipe in it. So in order for your nodes to work properly, this data has to be true, and all of those dependencies also have to exist on the Chef server. Everyone with me so far? Okay, so there's a kind of a social contract between you, your nodes, and the server that have all this data in it. There was some, let's call it upheaval in the Chef community over the past couple of years over this concept of roles. Okay, so roles are really cool because you can say this is a role web server. And for my role web server, here's my run list. And then I attach that role in my run list on all my web servers, and they're going to execute those roles every single time. The problem is roles aren't versioned. So if I have my web server role for my dev environment, my QA environment, and my production environment, and then I add a recipe because the devs come to me and say, hey, I need another recipe run on my dev environment, can you do that please? And I add it to my web server role, QA and prod just got it too, because roles aren't versioned. I can't say only this role for this environment, otherwise I have to create all these different roles. So that and a couple other things led to this concept of a policy file, where we basically take cookbooks and everything about cookbooks, everything about roles and nodes and run lists, and cram them together in this nice single artifact called a policy archive, and shove that into the Chef server as a single unit, which allows you to have a single item which says, this is the exact thing I want with all the cookbooks and everything all put together. So you don't have to worry about, did I upload that cookbook to the server? Is version 1.0 of that cookbook exactly what I think version 1.0 of that cookbook is? Where is the cookbook source? So let's dig into an example.
So are you kind of denormalizing your roles?
Exactly. You're basically serializing all of this data that you need for a Chef client to succeed, serializing it into a single archive and publishing that archive to the Chef server. So that way you have a known state with everything in it that you need to succeed. The model I was just showing you works totally well, and there's hundreds and hundreds of companies and thousands of people using that model. Policy Archive takes it and kind of smushes it down, so you have this known good that's versioned, stored in your version control, and all that other wonderful stuff that comes with it. So I'm going to go into my apps directory, and one of the Chef generate subcommands is app. I'll create a Surge app. There's nothing really special about the app other than it's a nice directory structure for developing a new application, and we'll go into it and Surge and look at it. So I've got my cookbooks directory, because an app would have cookbooks, right? So I'm also going to type Chef generate policy file. Right now, this isn't the default, but in a future version of Chef DK, every time you type Chef generate app block, it will also generate a policy file.
So is another way to look at this policy file as kind of like a manifest?
Yeah, the policy. So how many of you have used Chef before? And how many of you are familiar with something called Burkshelf? Okay, so Burkshelf is a community tool, came out of an open source tool out of the community that did this concept of cookbook dependency solving. Because as Nathan was showing you before in the delivery demo, cookbook A can depend on cookbooks B and C. And in order for cookbook A to succeed, cookbook B and C also have to be on your Chef server. So the onus is on you to make sure the right versions of those cookbooks are all pushed up to the Chef server so your clients will succeed and you have your appropriate end state. And Burkshelf was a tool created to do that dependency solving. You can think of policy file as Burkshelf plus a lot of other cool things that we've developed. Okay. So if I look at the policy file, you give it an application name, you tell it where to find the cookbooks. So the default that comes out of any time you create a policy file is community, which basically means supermarket.chef.io, the supermarket that Nathan was talking about before. You specify the run list that you want your node to actually execute. And then if you have any cookbooks that cannot be found on the community site, on the supermarket, you can tell it where else to find it, perhaps GitHub or my local workstation. So this is what we're going to do right now. I'm going to name my new application, my new policy, Surge. I'm going to leave that. I'm not actually going to use it, but that's fine. And I'm going to say I want you to run the Surge default, if I can spell, Surge default recipe, and I'm going to tell it my actual Surge cookbook can be found here locally. So I've got a Surge cookbook at cookbook/Surge. Okay, so right here, right now, I've got a working policy file. And the next step would be to say, hey, let's create my policy file .lock. So this is where your actual manifest comes into play. This lock file will describe everything about my local application that I need, that I want to package up. And the way we do that is type chef install. Chef install, it's kind of a weird name for the command, but what it's actually doing is doing that dependency solving for you. It's looking at my Surge cookbook, everything that's in my run list. It's looking at the metadata of each of those cookbooks in that run list to say, does this cookbook depend on any other cookbooks? Go out and grab them, figure out where they are, and save them locally, that I can then, once I've done all the dependency solving, now I've got my single artifact, I'm going to push it up. The output of the chef install is this policy lock file. So let's take a quick look at it. So there's a whole lot of, forgive the phrase, a whole lot of garbage on my screen right now, but it's all the information that Chef DK needs to know about where to find your cookbooks, the cookbooks it just pulled for you, and it versions everything with these sort of like git SHA-1 style hashes. So everything that it just installed, dependency solved, etc., now has a unique ID. So Chef can determine when these things change. So I've got a cookbook locks section here, which just says I found your local cookbook. It's at cookbook/Surge. I know some information about it, blah, blah, blah. No big deal. And then there's other information here about the different versions and other dependencies. Since I only have one cookbook, there's no dependencies on it. This policy file lock is a little empty. But as it stands right now, I've got a working cookbook. I can run Test Kitchen on this right now. And what will happen is exactly what we did in some of the demos when we had an empty recipe. We'll spin up a VM, we'll converge, there'll be 0 resources, everyone will be happy, we all profit. So right now is where I'll draw a line and say, this is my known good, I'm just gonna go ahead and commit this again.
All right, can you tell us about your cool command line?
My prompt?
Yeah.
I use Z-Shell, and this is one of the themes from Oh My Z, which if you're using Z-Shell, you should absolutely be using Oh My Z. And as your Git status changes, you'll see what branch you're on, if you have added files, and you'll see as soon as I commit this and I've got a clean working directory, that orange master turns green, which makes everybody happy, because if there's anything I know about computers, green is good. Okay. So I've committed, this is my known state, like I'm in a good state on my cookbook, it's all working, I'm happy. We'll pretend I did a kitchen test and yay, success. So this is clean. Now, I'm a developer and I realize I need another cookbook. It's time to iterate over this magical thing I've just created. So I'm going to loop in another cookbook. Maybe I want to, let's see, maybe I'll do a sudo array. So let's look at my cookbooks, Surge recipes. Okay, I am going to use another cookbook, which provides a sudo resource. And I'll just say Surge user. And this sudo resource is going to create a file at etc/sudoers.d/whatever I just put up here, in this case surge-user. I'm going to say the user that I want to give sudo access to is actually surge-user, and the command is, I'll just say all. Why not? Sudo all the things, root for everyone. And because the sudo resource isn't something native to Chef, it exists in the sudo cookbook, I need to tell Chef to depend on another cookbook. The way you do that is in the cookbook, my Surge cookbook's metadata file. So I'm going to edit the cookbook surge metadata.rb. And I'm going to say depends on the sudo cookbook. Now this is the depends keyword, super, super awesome, because not only can it automatically find cookbooks where it needs to, you can also version pin here. So if there's let's say I'm going to use version 2 of the sudo cookbook, they introduce version 3 and completely break me, I can say sudo version less than 3 and never pick up version 3 of that cookbook. So this is a great way of actually pinning known good versions. And if you have questions about that, see me after, because there's really cool things about pessimistic version matching that are common in the Ruby ecosystem. We also do here in Chef as well. So I've got my pen sudo. Now, I don't have in my cookbooks directory, there's only the surge. There's no sudo. So what I need to do is do that chef update or that policy file update so it can go and figure out those dependencies. How does that work? Well, let's look at my policy file again. And we see the default source community. And I know for a fact there is a cookbook on supermarket.chef.io called sudo. And I'm not going to specify it as a one-off or anything. I'm just going to let Chef DK do its thing. Go grab the cookbook. And the way I do that is by doing chef update. So it's still using my local surge cookbook, but what it's also doing is it just went out and it grabbed version 272 of the sudo cookbook from the community site. Now, it's also updated policyfile.log. How do I know that? Besides the fact that it outputted something to standard out, I can do get status.
Wait, are you saying it just updated policyfile.rb as well, or no?
No, policyfile.rb is my instructions on where to get things.
Okay.
It uses all the other metadata on my cookbooks to figure out what else to get, and then it updates the policyfile.log, which is all the dependency solve. So my workstation has done all that dependency solving that the Chef client has to do. I've done it here, one place, and that way I can enforce it everywhere. Okay. So we can see just by my git status, I've updated my cookbooks metadata RB and my default RB recipe. But I've also updated that policyfile.lock.json, or really Chef DK did that, the Chef update command did it. So I can do a git diff on policyfile.lock.json, and you can see the revision ID changed, some information about my cookbook change. You can see it now figured out I need to grab a sudo. This is all good. I'll get to your question in just a second. This is all great, except maybe not necessarily all that human readable. So there's a chef diff command. And if you pass --head, it'll do a diff against what your last git commit was. So remember when I drew that line in the sand and said I have a good known cookbook? Now I'm going to compare to what my last git commit was in a little more human readable format. So it'll tell you about certain things without you having to know about the structure of the policy file lock.json file. I've also shown you with some headers here, the revision ID has changed. We added a cookbook. The surge cookbook was modified. So now I know more information about this cookbook and about the changes. Your question?
Yeah, where does cookbook sudo get cached to?
It gets cached to a local hidden directory here, so it's similar to how the Burkshelf has its own local copy of the Burkshelf on my local machine. When I say I've got this known good thing, when you push this policy file, or really it's policy archive, up to the Chef server, all that cached cookbooks that are specified here in the policy file lock.json get pushed up together as well.
Is that in my home directory or is it in the repository?
Well, it's technically in this app directory, and it's actually in your home directory.chefdk/some weird path here, blah, blah, blah. So it keeps it locally. It's in a cache that's not meant for you to be mucking with, because that is a known good artifact you just fetched from somewhere, and the shop for that artifact is also stored in your log file. So that way you're never uploading a artifact that hasn't been sanitized by this whole policy file process.
But it's not in a directory that I need to worry about getting ignored.
Absolutely not. Yeah, you don't have to worry about that at all. Okay, so I'm going to go ahead and I'm happy with this. Everything is good. I've done my kitchen verify, and let's do a git commit again. Added sudoers, and now I can push this policy up to a chef server. And the way we do that is chef push, and I'll need a reminder. Right, chef push. I'm going to call this my surge policy group, and actually what I should have done is I'm going to push this up to staging because it already knows it's. I actually did an error there. What I should have said was I'm pushing this policy up as my staging. So my known policy, my policy log file, all my artifacts, all the cookbooks, everything that I needed to say this is a known good has now been pushed up to the Chef server as a single awesome policy file artifact that I can now go apply to servers. So I can go ahead and spin up a VM and say, hey, instead of you talking to the Chef server and getting this run list of stuff, go request this policy file instead. Does that make sense? Everyone with me so far? Yes? Okay. We're almost out of time, so I won't even go into some of the live demo, but I'll be happy to stay late and show you some live demo if anyone's interested. But the workflow here, once you've kind of stepped into this whole wonderful world of policy file stuff, is when I want to add another pseudoorders entry or add another cookbook, I can modify that cookbook, I can modify its metadata, I can do the chef update, regenerate that policy file, and push that up to the Chef server in my staging policy group or my production policy group without affecting all the other policy groups. This is really important because there's nothing preventing me from publishing 2 versions of the pseudo cookbook at version 2.7.2 with different contents. Like, that's a thing that happens. People can force update stuff on your local supermarket, your local Chef server. What you think is version 1.0 may change. I know that sounds incredibly ugly, but the fact is we're human. People make mistakes, things happen. The policy file workflow works around all of that. We don't really care what version of the cookbook says it is. We git shot everything. We checksum everything with the policy file workflow. So whatever you dependency solve on your workstation, whatever you test, whatever you bundle up into that chef push blob up to the Chef server is exactly what every single node is going to get. No matter whether someone changes the cookbook out of the supermarket, they delete the cookbook out of the Chef server, the policy file workflow is completely parallel to all of that. And it's really, really awesome. I know I didn't do it really a lot of justice here, but if you've used Chef and you're familiar with the knife tooling and how if you have 100 servers, you have to knife node edit 100 servers to update its run list, that is all in the past with policy files. You just tell the server, at least you're all web servers, you all talk to the web server policy file, and then you update that policy file in one location. It's version, it's in your Git, SCM, whatever. You use CVS, it doesn't matter, we don't care. It's all versions in this nice tight little artifact, and I would love to show you more. Swing by, see me afterwards. Come to the Chef booth tomorrow, I'll be there all day, except when I'm shoving food in my pie hole. I'd love to talk to you more about it. And anything else that was on that list. Any questions? Awesome.
All right, thanks, Adam.
Sure.
That's very cool. That brings us to the end of our day. So thank you all again very much for coming and hanging out. And you spent the whole day. You could have left at any time. And those of you that are still here, you're awesome. I mean, the people that left are awesome also. You're more awesome than they are. So thanks again. I hope you learned something. Enjoy the rest of Surge, and we'll see you over the next couple of days. Thank you.